and today we continue with our topic of discussion, and this is genetics. Today I would like us to discuss the causes of variation. During the last lesson, we discussed the two types of variations, that is continuous and discontinuous variations, and we gave examples. And from that, we want to find out what are the causes of those variations. Now, the first thing to note about variations is that variations can either be caused by genetic factors or environmental factors. The genetic factors are factors within us. For example, our gametes and so on and so forth, how fertilization occurs. But also these variations can also be brought about by occurrences that are taking place in the environment, that is outside our bodies. And we shall mention something that is called mutation. So basically we can say that variations are caused by both genetic and environmental factors. And these factors include, or the causes of variations include, one, the process of gamete formation. The process of gamete formation. When gametes are being formed, there is likelihood of variations occurring there. And this is why we earlier mentioned that even if two brothers are from the same parents, they do not look exactly the same. They do not look identical, because the process of gamete formation is different between the two. As we shall see. Now, in the process of gamete formation, I would like us to mention two processes. One that is called crossing over. That's one of the processes during gamete formation that brings about variation. And this crossing over, this is the exchange of genetic material between chromosomes, which takes place at prophase 1. Prophase 1 is the prophase of meiosis 1. We discussed the cell division at form 3 level. So we know the happenings that occur during this stage that we are referring to as prophase 1, whereby we say that the homologous chromosomes, they come together, they intertwine, and then an exchange of genetic material can occur there. So we are going to have an illustration of that. For example, I have a chromosome here. Of course, you know that the chromosomes are made of two parallel strands that we call chromatids, and those chromatids are joined together at the centromere, that is the center. And then I have another chromosome as well. Let's say we shade one so that we can be able to distinguish them. Although when we are drawing diagrams in biology, we are not supposed to shade, but I'm just using this to show the distinction that this chromosome is different from the other chromosome. So these chromosomes, when they come together and intertwine, we refer to this as synapses. Synapses, which is the intertwining of chromosomes. They intertwine at the point of intertwining at the chiasmata. This point is what we are referring to as chiasma. This is another chiasma. So when there are two, they are called chiasmata. Chiasma is the singular. They intertwine. First of all, they move close to each other, then they intertwine at the chiasma. And whatever is formed, forming bivalence. So for example, the whole of this structure is a bivalent. So forming bivalence. So after intertwining, an exchange of genetic material will take place. An exchange of genetic material will take place such that when they break apart, when they reach the point whereby they'll separate, so we can now remove the chiasma. They have broken apart. So there is this section that was in this chromosome that has been transferred to this other chromosome. And there is this section that was in this chromosome that has been transferred to the other chromosome. So that is the point that leads to the exchange of the genetic material. So the genes that were in that particular section have been exchanged. They have been transferred from this chromosome to this, and some have been transferred from this chromosome to the other. So we are calling that crossing over. And it's one of the causes of variation during gamete formation. So we are saying that it is the exchange of genetic material between chromosomes which take place at prophase 1. So this process occurs at prophase 1. Another area where the another stage in gamete formation where the variations can occur is what we call the independent assortment, which occurs during metaphase 1. Now, independent assortment simply means the random assortment. This is whereby the next stage after this, after prophase 1, the chromosomes will move on to metaphase 1, whereby they will be aligned at the equator of the spindle fibers. So the alignment of the chromosomes, while still as bivalents, at the equator of the spindle is random. So they can be aligned in a particular manner, or they can be aligned in a different manner. So there are various ways in which those chromosomes can be randomly aligned at the equator of the spindle. So we are saying that the alignment of chromosomes, that is homologous chromosomes, while still as bivalents, is random. and that is what we are calling independent assortment. We'll illustrate that. So it's random, and then after that random assortment, after they start now separating, they can separate in different manners. So for example, that one can go to that daughter cell, this one can go to that particular daughter cell, this one can go to this daughter cell, this one can go to that daughter cell. So there are different ways in which they can lead to different daughter cells where they'll become gametes. Of course, transferring some variations to that gamete, and on the other side transferring some gametes. So we'll have an illustration. For example, we have this is a chromosome, and assuming its pair is this, a smaller one, so that is one way in which the chromosomes can be assorted. So this one can go to one daughter cell, and this pair can also go to the other daughter cell. So this is one way in which random assortment can happen. On the other hand, you may have this and this going together, and these ones go to a particular daughter cell, while the ones I'm using a smaller size and these ones can go to a particular daughter cell. So this shows the first situation and the second situation. So this shows a random assortment of homologous chromosomes. So there are so many ways in which the chromosomes can be assorted in different ways, leading to very many variations. So this one can go to one daughter cell, this one goes to another daughter cell, carrying its own genes there. On the other hand, still within the same process of gamete formation, these ones can go together and these ones can go together, carrying different genes into a certain daughter cell. So that random assortment, or that independent assortment that occurs during metaphase 1 is what we are saying that is another cause of variation during the process of gamete formation. So gamete formation is one process that leads to variations, either during crossing over or during independent assortment. But just to elaborate that point on independent assortment, for example, in humans, we have 23 pairs of chromosomes. That means 46 chromosomes in every somatic cell. So in this case, what can happen, if we have 23 pairs of chromosomes, then it means the number of independent assortments possible is 2, because we have paired chromosomes, raised to power 23. Those are the number of times we can have different assortments in in our chromosomes during metaphase 1, because we are saying that in humans we have 23 pairs. So 23 becomes the power. The 2 for the pair can have 23 to the power of 23, as in the number of times it can be assorted. So if you calculate this value, you will get something that, that is above 8 millions number of ways in which this can happen. In fact, if you are to get a calculator and say 2 raised to power 23, then it's going to give you a figure that is above 8 million, the number of times we can have different assortments out of the 23 pairs that we have. So that is one likelihood of variations. Number 2, variations occur during fertilization. Also occur during fertilization, and this is whereby the male gamete nucleus fuses with the female gamete nucleus to form a zygote. So in other words, we are saying that the zygote will carry the genes that were on the male gamete nucleus and those that are in the female gamete nucleus in different combinations. So basically we are saying that the gamete that fertilized the first time may not be identical to the one that will fertilize the second time. So, and this is why we are saying that even the siblings who are of the same parents, they do not show complete identity, or they are not completely identical because of fertilization. Also, there is another cause of variation, and this one is basically environmental, and this is now during mutations. And you can see that mutations, these ones are spontaneous, or you can say that they are inheritable. They are inheritable changes in genetic constitution of an organism. The inheritable changes in genetic constitution of an organism, and these mutations are caused by mutagens. Mutagens are the ones that cause mutations, and we have examples of mutagens, e.g. We have things like radiations, such as the UV, ultraviolet rays. They have been associated to be some of the radiations that that cause the genetic constitution of an organism to change. And when the genetic constitution changes, then it is transferred to the offspring, especially those mutations that affect the gametes. You can say that mutations that affect gametes are inheritable. They are inheritable because gametes can be they are transmitted from parents to the offspring. So the most significant mutations are those that happen in the gametes because they are passed on. So if there are changes that happen, then that is likely. So we are saying that mutagens include radiations, even gamma radiations, gamma rays. We even have chemicals, chemical mutagens, all these that cause mutations. E.g., we have what we call the mustard gas. So all these colchicine. So those are some of the chemicals that may cause the inheritable changes in genetic constitution, what we are calling mutations to happen. So we are going to stop there and have an assignment. So the assignment, explain how the following processes lead to variations. A, crossing over. B, independent assortment of chromosomes. And C, mutations. So we are going to stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello and welcome to our today's lesson, History and Government. We are learning about the establishment of colonial rule in Kenya. That is the topic that we are learning, and we been learning about the Kenyan society's response to the process of colonization by the British. And just as a matter of remembrance and overview of what we have already covered, is that we mentioned that the European or the Kenyan communities reacted in different ways towards the invasion by the British in their territories. What are these ways? Which are these responses that the Kenyan communities instituted against or towards the British? Are you able to remember them? We said there are three ways in which, or there are three responses that the Kenyan communities responded to the process of European colonization in Kenya. What are these three ways? He said, number one, they resisted. There was resistance. They came up in arms against the British occupying their land. Some of the communities that resisted include what? The one that we are studying, that is the Nandi. Which are the other communities that resisted? We mentioned that in our introductory lesson. We said the other one is the Agriama. We also mentioned the Bukusu and the Somali. Apart from resistance, which was the other method? We said number one, we have resistance. Number two, which is the other response that the Kenyans gave towards the British. The other one was collaboration. Very good. They collaborated or cooperated or accepted the rule in exchange of protection and other things. And there are two communities that collaborated with the British in Kenya. That is the Maasai and the Wanga. That is in among the Western Bantus. Also, there was a third response which we classified or which we called the mixed reaction or mixed response. That is, portion of the community was collaborating with the British while the other was resisting, or initially they collaborated and later on decided to resist. An example are the Agikuyu. So those are the responses, and that is what we are tackling. But now in our today's lesson, and under the Nandi resistance, in our previous lesson we looked at the factors or the reasons why the Nandi resisted the British rule, and we mentioned and discussed them in detail. And then in our last lesson we also discussed the cause, how they fought, what initiated the war, how they fought against the British, and the expeditions that were sent by the British against the Nandi. And we also outlined and discussed the reasons the factors that made the Nandi to put up a prolonged resistance. Remember, we said they started their resistance in 1895, and that resistance lasted up to 1905 when they were finally defeated. by the British. So we mentioned the reasons why they put up such a prolonged resistance. Are you able to remember the reasons why they resisted for quite a long time? The reasons included the terrain that they were living in. The mountainous terrain was well known to the Nandi warriors, but the British, who had come with their weapons that needed to be moved around, could not adapt to that terrain. So the terrain encouraged them to use guerrilla warfare. They could attack, then go and hide in the mountains and the hills, so the British could not advance against them. Apart from that, they had a sense of pride. They were not easily going to give up to foreigners coming to take up their land. Apart from that, they had a very strong and able leadership that was provided by the institution of the Orkoiyot. And the Orkoiyot at that time was Koitalel Arap Samoei. Should remember that. So this man provided direction. He organized the army. He organized the community to fight against the British. Which other factors enabled or led to the Nandi putting up a very strong resistance, or a prolonged resistance for quite some while? The other one was military experience. They were able, or they had been involved in other kinds of war with their neighbors. So these enabled them to continue fighting, and they had amassed a lot of experience. Their warriors were experienced to fight because that was a norm to them. They could raid their neighbors at will. They could raid the Gusi, they could raid the Luo, they could raid the Nandi, the Maasai, because they were quite a strong people, and they were well trained. Apart from that, they had a very large army, a very large supply of army, that each and every time they were men who were ready to fight on behalf of the community. Also, they had a steady supply of food, such that even when the British employed the strategy of scorched earth policy, that is the burning down of the crops of the Nandi and killing some of the animals, because of the vast nature of the livelihood or the economic strength of the Nandi, they were able to have a steady supply of food. So their warriors were well fed and they were strong. And then finally, we also discussed the impact of the climate on the British. They could not be able to sustain, or they could not be able to fight effectively, because the climate in the highlands was quite cold, and they could not be able to resist the diseases, the tropical diseases that attacked them. So those are some of the reasons why the Nandi were able to give such a prolonged resistance. So in our today's lesson, we are going forward to learn what are the factors or the reasons that led to them being defeated. The factors that led to them being defeated, that is one. And then number two, the results of their resistance against the British. So allow me to start with the first part, which is reasons, or you can refer to that as factors for their defeat. And when you talk of their defeat, let me write the Nandi, right? The Nandi defeat. Why were they defeated? The factors that contributed to them being defeated. The first one is that some African communities supported the British. An example are the Maasai that were conscripted by the British, and they helped the British to fight against the Nandi. Remember, the Maasai were traditional rivals of the Nandi. The Nandi constantly raided the Maasai community. So with that hatred, the Maasai joined up together with the British to fight against the Nandi. So that contributed to the Nandi being defeated. Actually, this happened in 1905. You should not forget that. So apart from the Maasai, we also had the Somali. We also had the Somali that also took part in helping the British to fight against the Nandi. Even as such, other communities around the Nandi did not come to support the Nandi to fight against the British. An example is the Luhya community. It did not come to aid or support the Nandi as they fought against the British. That is the first reason. Some African communities supported the British, while other communities, right? While the other communities did not come to support the Nandi. So you can imagine if other communities could join in arms together with the Nandi, they could have easily defeated the British. But now, because that was not the case, that brought them to, it resulted to them being defeated. Then the other reason or the other factor was the British had superior weapons. The British had superior weapons. The Africans or the Nandi were using rudimentary arms. They used arrows, they used daggers, they were using spears, as opposed to the British who are having rifles and machine guns. The Nandi were using spears, they were using arrows. So they did not, they are comparing between a spear and a gun or a machine gun. Which one is likely to outdo the other? That is why the Nandi ultimately were defeated, because the armies or the British army had superior weapons compared to those of the Africans. The Africans had not amassed the technology of creating guns. Remember, even as we are talking during this period, there were no industries of producing arms in the Kenyan territory. So that made a contribution towards the Nandi being defeated by the British. Apart from the superior weapons that they had, there were natural calamities. There were natural calamities. There were natural calamities that influenced or made them to be defeated. An example is the rinderpest. The rinderpest is the rinderpest that attacked their animals and led to most of the animals dying, thus making them to lack food. So when they were attacked by this pest, they were unable to sustain their economy. They were also attacked by smallpox. Smallpox. This is a disease that they did not have initially. So when they were attacked by this disease, it weakened most of them, and most of the warriors were affected. They could not effectively fight. So the natural calamities that came, this is not a result of the British. It was just a natural occurrence that really affected them, and it interfered with their way of fighting or with their way of going against the British. Let us take a step further and look what are the other factors. Number 4, the next factor, number 4, is the British used the scorched. The British used the scorched earth policy. This is where, or this involves the British going to, or after they have attacked the Nandi at one place, they could come down and burn down. They could burn and destroy the crops and the animals that had been left by the Nandi while they were running away. Remember, the Nandi were using the guerrilla warfare. They would come and attack the British and then run away from their homes to go and hide in the mountains, to go and hide in the forest. So these, they left their homes unattended to. So when the British came together with their collaborators, they would burn down. They would burn down their crops. They would destroy their silos. They would destroy their granaries. So when the Nandi came back, they were unable to get food. So the scorched earth policy, to some extent, also contributed to weakening the defense or the resistance by the Nandi, and ultimately they were defeated. And then lastly, or the last factor that made them to be defeated, was the death of Koitalel Arab Samoei. The death of Koitalel Arab Samoei. So this was the leader, or the Orkoiyot. He was the Orkoiyot at that time. And remember, the Orkoiyot was a very essential person in the Nandi community. He was the overall leader. He was. It was the institution that brought together the members of the Nandi community. So they are Orkoiyot, who was at that time known as Koitalel Arab Samoei, was tricked by the colonel of the British and was captured and eventually killed. So that demoralized. It demoralized the warriors. It demoralized the warriors. So the warriors could not mount up an effective attack against the British as they had done under Koitalel, because Koitalel was the spiritual leader and he also led the community in its wars or in its expeditions against the enemies. So these weakened, or it made them to lack direction. The leaders who took over control after the death of Koitalel Arab Samoei could also not match up the organizational skills of Koitalel Arab Samoei. So the death of Koitalel Arab Samoei was, we could conclude that was the final nail to the coffin of the resistance of the Nandi, because they were now unable to effectively fight against the Nandi. So these are some of the reasons that contributed to them being ultimately defeated. And as we mentioned in our last lesson, they were defeated in the year 1905. So now that they have put up a fight, they have fought against the British, and they have finally been defeated. What were the consequences? What were the results of their resistance? So let us take a step further and look at the results. The results of the Nandi resistance. The results of the Nandi resistance. What were the consequences? What were the outcomes of their resistance against the British? Number one, loss of life. Most of the warriors lost their lives as they resisted the British. Remember, the British are using superior weapons, the machine guns and the rifles, the repeater rifles. So these led to most of them losing their lives. It is estimated that thousands of around 1,000 of warriors lost their lives during that period of their resistance. There was a lot of loss of life. most of their lives were lost during the resistance. And then number 2, they lost their land. Loss of land. So the fertile land, the land that was very fertile, that was producing the food they were using, was now taken over by the British. So they lost their land to the British ultimately, because now they have been defeated. They cannot continue to occupy that land. So the British came and took over the land. And while they were taken, or their land was taken up, the Nandi were pushed into reserves. The Nandi were pushed into reserves. Most of them, because now their fertile land has been taken away for the British settlers. The Nandi were now forced to move into the less productive land. And others were even left to become squatters in the land that the British were living in. So that was another consequence. The fourth one is that they lost their prestige. They lost their influence or prestige. They lost their influence. Remember, the Nandi were the expendables in that area at that time. They believed they could not be defeated. But now that the British have come and have finally defeated them, they now lost their influence in the region. They could now not be feared the same way they had been feared before. Let us look at some other reasons, or some other results of the Nandi resistance. So the fifth one, most of the Nandi warriors were conscripted into British service. Now, because of their military skills and their ruthlessness, the British conscripted or forced the Nandi warriors to work as policemen, and also to join into the army. So they were now able to work under the British government, and also they lost their independence. They lost their independence. They lost their independence. And then lastly, they were displaced. They were displaced from their original areas of occupation. So as the British advanced and took over their land, the British, or the Nandi people, were displaced into other areas. Some of them had to move away from their home. So those are some of the results or the consequences of the Nandi resistance against the British. And now I would give you a revision question as we end our lesson. Remember, we have been discussing the reasons why the Nandi resistance was defeated and the results of their resistance. So revision questions. I'm going to give you 2 questions. And the first question is, discuss the reasons why the Nandi resistance was subdued. And then number 2, explain the consequences of the Nandi resistance against the British. Number one, discuss the reasons why the Nandi resistance was subdued. And number two, explain the consequences of the Nandi resistance against the British. And I'm sure those are the very easy questions that we have effectively tackled in our today's lesson. Thank you for having time to study with me. Until the next time we shall meet for a history and government lesson. Bye bye.
Welcome to Manifested Publishers.
Hello learners, welcome to chemistry lesson. My name is Mwaniki. We are learning chemistry and the topic is gas laws. Remember, the forum is still Manifested online classes. In our previous lesson, we derived the formula for Boyle's law, where we said that V1 P1 is equals to V2 P2. And we said that V1 is the initial volume, P1 is the initial pressure, V2 is the final volume, and P2 is the final pressure. That is the formula we will be using to do some calculations involving Boyle's law. In this lesson, we are going to discuss the units of pressure. We want to discuss some of the units you can use to measure pressure with. The standard unit of pressure is called Pascal. The standard unit of pressure is Pascal. So Pascal. That is the standard unit of pressure. 1 Pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared. So 1 Pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared. Therefore, we can say that 1 Pascal is equivalent to 1 Newton per meter squared. 1 Pascal is equivalent to 1 Newton per meter squared. Another unit of pressure, well, pressure can also be measured using atmospheres. Using standard atmosphere or just ATM, so abbreviated as just ATM, can also be measured using standard atmosphere. And we say that 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. That is another unit of pressure. And lastly, pressure is also measured using millimeters of mercury. Written as mmHg. Remember, Hg is the chemical sample of mercury. So these are also units of pressure. And we say that 1 atmosphere pressure is equivalent to 760 millimeters of mercury pressure. 1 atmosphere is equivalent to 760 millimeters of mercury pressure. Therefore, those are our 4 units of pressure, which are pascals, being the first one. The second, we have said, are newtons per meter squared. And we have this illustration, or this illustration where we say that 1 pascal is equivalent to a force of 1 Newton exerted on an area of 1 meter squared, meaning it's an area of 1 meter by 1 meter, so that it is 1 meter squared. The third unit is standard atmosphere, or just atmosphere, standard atmosphere. And again, we've said that 1 atmosphere pressure is equivalent to 101,325 Newton per meter squared. Those are units of pressure. And lastly, I have said that you can also use, or pressure is also measured using millimeters of mercury. And I have said again that 1 atmosphere is equivalent to 760 millimeters of mercury. So always understand those relationships, because again, sometimes you'll be required to convert either millimeters of mercury to atmospheres, or atmospheres to millimeters of mercury. I also want us to do some applications or some examples of Boyle's law. So we now get some examples or the applications of Boyle's law. And the first example I have this example. Let me write it for you. What is the first example? So if 60 centimeters cubed of oxygen is compressed from 20 atmospheres pressure to 40 atmospheres pressure, what is the new volume of the gas at constant temperature? So temperature must always be constant. let's do the question. So the solution would be, so first of all, you need to understand or need to know the expression or the formula for calculating Boyle's law. And you say that the formula is V1 P1 is equals to V2 P2, where we say that V1 is the initial volume, V1 is the initial volume, P1 is the initial pressure, V2 is the final volume, and P2 is the final pressure. So in our case, we have the first volume, or V1 is 60 centimeters cubed. P1 is 20 atmospheres. V2, this is now what we are looking at, or we are looking for, and P2, final pressure, is 40 atmospheres. 40 atmospheres. Therefore, we still have our formula V1 P1, which is equals to V2 P2. We want to make V2 our subject. Therefore, we have to divide this one by P2. Then we divide this by P2. When divided by P2, this P2 will cancel out on the right side. And you'll be left with V1 P1 divided by P2 is equals to V2. Therefore, you get the V2 from this. And you already have the V1, P1, and P2. Therefore, you just need to substitute. V1 is 60 centimeters cubed, multiplied by P1, which is 20 atmospheres. You divide by P2, which is 40. This one, if you calculate using your calculator, it will give you, that is now 60. You multiply by 20. Multiplied by 20, it gives you 1,200 divided by 40. And this gives you 30. And therefore, V2 is 30 centimeters cubed. It is important to include the units because we are calculating the volume, and this volume is in 30, or is in centimeters cubed, sorry. It's in centimeters cubed. So it is important to include the units of measurement. That is the first example. I want to give you the second example so that you understand better. The second example is a certain mass of a gas occupies 500 centimeters cubed at 100,000 pascals. What will be its pressure? What will be its pressure at 1,000 centimeters cubed? Solution to this, remember our expression is still V1 P1 is equals to V2 P2. 2. And our V1 is 500 centimeters cubed. P1 is 100,000 pascals. V2 is 1,000. P2 we don't have, and that is what we are looking for. Therefore, using the expression V1 P1 is equals to V2 P2, we don't have P2, and that is what we are looking for, and therefore need to make P2 our subject, and we'll make P2 the subject by dividing both sides with V2. Divide both sides with V2, then this V2 will cancel out, and you will be left with V1 P1 is equal, you divide by V2 is equals to P2, and P2 is now what we are calculating from our question. The next step, you just need to substitute. V1 is 500 centimeters cubed. You multiply by P1, which is 100,000 pascals, divide by V2, which is 1,000. Therefore, if you do the calculation using your calculator, that is 500 times 100,000 that gives you 50 million. And divide this by 1,000. You'll get 50,000. 50,000, because we are looking for pressure, then you must include the units of pressure. Therefore, it's 50,000 pascals. That is how simple the questions are, and therefore you should be able to do as many questions as possible, so long as you have the expression V1 P1 is equals to V2 P2. That will be a very great equation, or very important when you'll be doing the calculations involving Boyle's law. That is our lesson for today. But before I end, I want to do a small recap on whatever we have learned. We have learned the units of pressure, which are 4. It can be pascals, can be Newton per meter squared, can be standard atmospheres, and millimeters of mercury. And we have done 2 applications of Boyle's law. The application number 1 was if 60 centimeters cubed of oxygen is compressed from 20 atmospheres pressure to 40 atmospheres pressure, what will be the new volume of the gas at constant temperature? And we have our expression V1 P1, which is equals to V2 P2. Then from the question we have isolated, V1 is 60 centimeters cubed, P1 is 20 atmospheres, V2, this is what we are calculating, and P2 is 40 atmospheres. Therefore, because we are looking for, or we are calculating V2, we need to make V2 the subject of the formula. Therefore, from this expression, we have to divide both sides by P2. If on the right side, the P2 will cancel with the P2, and the V2 will be left as the subject of the formula. And that is now what we have at this point. Now from there, the next step is substitution. That once you substitute, then V1 is 60, P1 is 20, P2 is 40. Therefore, 60 times 20 is 1,200. To divide by 40, this will give you 60. And therefore, the V2 is 30 centimeters cubed. And I've told you again that units, again, you must include the units because they are so important. That shows that those are the units of measurement of volume. In the second example, was a certain mass of a gas occupies 500 centimeters cubed at 100,000 pascals. What will be its pressure at 1,000 centimeters cubed volume? And therefore, again, expression V1 P1 is equals to V2 P2, where the V1 is 500 centimeters cubed, P1 is 100,000 pascals, V2 is 1,000 centimeters cubed, then P2 we don't have, and that is what we are calculating. Therefore, because we are calculating for P2, we need to make P2 the subject of the formula. And therefore, you divide both sides by V2. Then when you divide both sides by V2, now this V2 and this V2 will cancel out, and you'll be left with P2 as a subject of the formula. And you now do the substitution. V1 is 500 centimeters cubed. Then you multiply by P1, which is 100,000 pascals. Then you divide by 1,000, which is the V2, and you'll get 50 million. Divided by 1,000, then you'll get 50,000 pascals. Again, the units are so important, you need to include them at the end of the calculation. So that is the end of our lesson. But I'll leave you with one more question as your assignment. And this is the question. The assignment is, at constant temperature, a gas with a pressure of 750 millimeters of mercury occupies a volume of 80 centimeters cubed. What will be the pressure of the gas if it is expanded to occupy a volume of 340 centimeters cubed? That is the assignment. Therefore, ensure that you've done the assignment before we meet in the next lesson. Thank you for being part of the lesson. Bye. We meet in the next lesson where we do some more calculations involving Boyle's law. Thank you.
Welcome to Manifested Publishers.
Karibu sana mwanafunzi. Tuko pale pale katika masomo ya mtandaoni ya Manifested. Hapo awali tulikuwa tumeshashughulikia ushairi, tukaangalia baadhi ya istilahi zinazotumika katika mashairi. Lakini leo hii nataka tuweze kushughulikia mambo mawili. Hivyo basi lengo letu la leo ni kwamba kufikia mwishoni wa hiki kipindi uweze kuelewa kategoria mbili za mashairi na sifa zake. Jambo la pili ni kuelewa na uweze kueleza bahari mbalimbali za mashairi. Lakini hata kabla ya sisi kuelekea huko kwa bahari na kategoria, wacha tu kidogo tuweze kuangazia kidogo kuhusiana na yale ambayo tulikuwa tumezungumza hapo awali kuhusiana na ushairi, maana yake na baadhi ya istilahi. Iwapo unakumbuka, basi tukasema kwamba bado tuko katika mada kuu ambayo ni ushairi. Na nikawaeleza kwamba katika kile kipindi kingine tulikuwa tushapata maana ya shairi, ambapo tulisema ni utungo wa kisanaa wacha nitumie, ni utungo wa kisanaa wenye lugha teule. Lugha teule, naomba kufuta tafadhali. Unaotumia lugha teule mpangilio maalum wa maneno. Unaotumika katika kuwasilisha ujumbe. Wanafunzi, kumbuka kwamba hivi ndivyo vitahiniwa. Unapoeleza dhana hii ya shairi, unapoeleza maana yake, kumbuka kutaja kwamba ni utungo wa kisanaa. Kumbuka kutaja kwamba unaotumia lugha teule. Sio lugha tu hivi hivi, lugha yote, la hasha. Ni lugha iliyoteuliwa kwa weledi mkubwa sana, tena zaidi, na mpangilio maalum wa maneno. Maneno yanapangwa kiasi kwamba yanaweza kuwasilisha ujumbe wa msanii. Na basi kazi yenyewe ya huu utungo wa kisanaa wenye lugha teule na mpangilio maalum wa maneno ni kuwasilisha ujumbe. Haya, hapo basi katika hicho kipindi bado tukaangazia baadhi ya istilahi. Istilahi, hili neno istilahi kwa kimombo naweza nikakwambia kwamba ni kama vile terminologies. Terminologies ama terms, yani ule msamiati ambao unatumika katika uwanja wa mashairi. Moja kati ya hizi istilahi ambazo tuliweza kuziangazia ni mishororo. Baada ya mishororo tukasema kwamba mishororo ni ile mistari katika ubeti, ni mistari katika mashairi. Umeangalia shairi tu ukaona kwamba limeundwa kwa mistari. Kuna mstari wa kwanza, wa pili, wa tatu, wa nne. Yani hiyo ndio ambayo tunaita mishororo. Hii mishororo ikiwa miwili, mitatu, minne, mitano inaweza ikaunda beti. Ukiwa mmoja utaitwa ubeti, zikiwa nyingi zitaitwa beti. Aya, tukaangalia tukaona kwamba mishororo hii pia inaweza ikawa na vipande. Kimoja tutakiita kipande, vikiwa vingi viitwe vipande. Na tukaona kwamba hivi vipande vinaweza kuwa kimoja, viwili, vitatu ama vinne katika mshororo mmoja. Ambapo tulisema kwamba kipande cha kwanza kitaitwa ukwapi, cha pili kiitwe utao, cha tatu kiitwe mwandamizi, cha nne ukingo. Sio hizo tu, tuliangalia istilahi nyingine nyingi zaidi, ambapo na kutuma rejelea hicho kipindi ili uweze kufahamu zaidi kuhusiana na haya. Tukaangalia vina, tukaangalia mizani, tukaangalia manju ni nani, tukaangalia pia malenga, tukamwangalia shaha. Aya, hivyo basi nafikiri umeweza kupata picha halisi ya yaliyoshughulikiwa hapo awali. Lakini kwa leo, kama nilivyokueleza, ni kwamba tunaweza kushughulikia tafadhali. Haya basi, nafikiri mwanafunzi umepata picha halisi ya yale ambayo yalishughulikiwa katika kipindi hicho ambacho kilitangulia. Haya basi, kwa leo nilikuambia lengo letu kuu leo ni kuangalia kategoria mbili kuu za mashairi, na kila moja yazo tuweze kujua baadhi ya sifa zake ili uweze kupata tofauti kamili. Zaidi tutaweza kushughulikia pia bahari mbalimbali za mashairi ya Kiswahili. Haya basi, wacha ni ufute huu bao tuweze kuanza upya sasa somo letu la leo. Kategoria za mashairi. Msikilizaji, mwanafunzi, hili neno kategoria nafikiri unaona kwamba limetoholewa tu. Kategoria kutokana na neno category, na unajua category, kategoria ina maana ya aina. Hivyo basi tunazungumzia tu aina za mashairi. Isije kuwa ngumu kwako kuelewa kwamba tunazungumzia aina za mashairi. Mashairi yamegawika mara mbili kwa kigezo cha wakati na muundo wa nje. Kwa kigezo cha wakati na muundo wa nje. Aina ya kwanza ni haya mashairi tunayoyaita mashairi ya jadi. Mashairi ya jadi. Pia haya mashairi utapata pia yanaitwa mashairi ya arudhi. Yana neno jingine, yanaitwa pia mashairi ya kimapokeo. Kimapokeo. Ni mashairi ya arudhi, ni mashairi ya jadi, ni mashairi ya kimapokeo. Haya mashairi ni ya jadi, ni ya arudhi, ni ya kimapokeo kwa ajili ni mashairi ambayo yanafuata, ni mashairi yanayofuata kanuni au arudhi za utunzi wa mashairi. Wacha tu niandike kidogo hapa hivi kwamba ni mashairi yanayofuata kanuni au kaida au sheria za utunzi wa mashairi. Au kanuni, kaida, sheria za utunzi. Mashairi yoyote ambayo utapata kwamba yametungwa kwa kuzingatia kanuni, kaida, sheria za utunzi wa mashairi, hizo ama hayo mashairi ndio ambayo tunaita mashairi ya jadi, mashairi ya arudhi, au ukitaka mashairi ya kimapokeo. Ningependa uanze kujiuliza hivi, hizi sheria ama hizi kanuni, kaida hizi za utunzi wa mashairi ni gani? Hizi sheria ni gani? Kwanza, kaida zenyewe ni gani? Kaida zenyewe ni gani? Kwamba shairi lipangwe katika beti. Shairi lipangwe katika beti. Shairi lipangwe katika beti. Kuwe na kama unakumbuka katika hicho kipindi kingine tulisema kwamba ubeti ni fungu la ama ni kifungu cha mishororo. Ati sasa shairi linafaa liwe na ubeti wa kwanza, wa pili, wa tatu, na kuwe na usawa katika beti zenyewe. Pia shairi lipangwe katika mishororo. Ubeti uwe umepangwa katika mishororo, na mishororo yenyewe ijitosheleze kimizani, kivina. Unaona? Shairi lipangwe katika mishororo. Yaani ubeti wa kwanza uwe na idadi fulani ya mishororo, ubeti wa pili uwe na idadi sawa ya mishororo kama ilivyokuwa katika ubeti wa kwanza, ubeti wa pili hivyo, wa tatu, wa nne, wa tano jinsi hiyo. Ni sheria, ni kanuni, ni kaida ya utunzi. Hizo ndizo zinazoitwa arudhi. Aya, mishororo pia kuzingatia sheria ya mizani. Zaidi, wacha tuangalie kanuni nyingine ni vina. Ya? Shairi lako unapolitunga, wana mapokeo walipendekeza kwamba lazima liwe na vina. Na kama unakumbuka vina tulisema ni nini? Ni zile silabi za mwisho katika ukwapi au utao au mwandamizi au ukingo. Hizo silabi za mwisho. Wana mapokeo waliamini kwamba lazima hilo shairi liwe na vina. Pia suala jingine la kibwagizo. Mwanafunzi, msikilizaji, mpenzi wa mashairi ya Kiswahili, hivyo basi unapotunga shairi la kimapokeo, hakikisha kwamba umefuata hizi kanuni. Upange kazi yako katika beti, katika mishororo, mizani, vina na kibwagizo. Hiyo ilikuwa ni kategoria ya kwanza ya mashairi ambayo ni mashairi ya jadi au kitaka arudhi au kitaka mashairi ya kimapokeo. Malenga ambao wanafuata huu mkondo wa utunzi wa mashairi haya wanaitwa wanamapokeo. Wanamapokeo. Wanaitwa wanamapokeo. Yaani ni malenga. Ni wale malenga ambao hufuata mkondo wa kutunga mashairi kiarudhi. Hufuata ule mkondo wa kutunga mashairi kiarudhi. Kiarudhi kumaanisha kwamba wanafuata zile kaida, kanuni, sheria ambazo ni za beti, mishororo na mizani. Kategoria ya pili. Kategoria ya pili ni mashairi huru. Mashairi huru. Mashairi huru. Angalia neno kwamba ni huru. Ya? Wakati huu mwingine tulisema kwamba ni mashairi yanayofuata kanuni au kaida au sheria. Haya mengine unasikia ni mashairi huru. Basi bila shaka unajua kwamba ni huru kiasi kwamba huyu mtunzi, huyu malenga anayetunga haya mashairi ako huru kuwasilisha maudhui yake, ujumbe wake bila ya kubanwa na kanuni yoyote ile. Yeye si lazima beti zake zikawa na idadi sawa ya mishororo, si lazima kazi yake ikawa na vina, si lazima kazi yake ikawa na mizani ambayo inatoshana katika kila mshororo. La hasha, huyu ako huru. Na basi haya mashairi huru unaweza ukasema kwamba ni mashairi yanayotungwa bila kufuata kanuni au arudhi. Na ndio maana unapata kwamba kuna baadhi ya wataalamu mbalimbali unapata kwamba wako na visawe vya hili neno mashairi huru. Basi utapata kwamba pia huitwa, utapata linaitwa mapingiti. Utasikia yanaitwa pia mashairi ya kimapinduzi, ya kimapinduzi. Utasikia pia yanaitwa zuhali, masivina. na kadhalika. Hivyo ni visawe vya mashairi huru. Ningependa uweze kuelewa kwamba haya mashairi huru huwa yana sifa yake ya kipekee. Unapata kwamba ubeti mmoja unaweza kuwa na mshororo wa kwanza uko na mizani 13, mshororo wa tatu uko na mizani 6, mshororo wa 4 una mizani 17, mshororo wa tatu wa tano una mishororo 4. Yaani kumaanishaje? Kwamba huyu mtunzi wa kimapinduzi hajabanwa na kanuni zozote za utunzi. Aya, mwanafunzi, ningependa tuweze kuangalia sifa za kila aina, kila kategoria. Tuangalie sifa za mashairi ya kiarudhi ama mashairi ya jadi. Sifa za mashairi ya jadi, ambayo pia tulisema ni mashairi arudhi ama ukitaka pia yaite mashairi ya kimapokeo. Na utapata kwamba haya mashairi huwa yanakuwa na sifa kama zifuatazo. Sifa ya kwanza ni yana urari wa vina. Urari wa vina, yaani kuna ule mtiririko fulani wa vina, kuna mkondo fulani unaofuatwa na vina. Unaona, vina vinaweza vikatiririka ama vikabadilika, lakini kuna hiyo sheria ya kuhakikisha kwamba kuna ule urari ama ule mtiririko wa vina. Pia kuna sifa nyingine ambayo ni urari wa mizani katika mishororo. Unapata kwamba mshororo wa kwanza una mizani 16, wa pili una mizani 16, wa tatu una mizani 16, wa nne vivyo hivyo mizani 16. Huo ndio tunaita urari wa mizani. Basi kuna sifa ya mishororo. Mishororo sawa katika beti. Mishororo sawa katika beti. Unapata kwamba ubeti wa kwanza una mishororo 4. Ubeti wa pili una mishororo 4. Ubeti wa tatu una mishororo 4. Yaani vivyo hivyo unapata kwamba mishororo ni sawa katika beti mbalimbali. Zaidi unasikia kwamba pana uwezekano wa kuwa na mishororo kifu. Hii ni mishororo ambayo imejisimamia kimaana. Haihitaji ujumbe kutoka kwenye mshororo unaofuata. La hasha. Mishororo kifu. Ama pia utasikia ikiitwa mishororo toshelezi. Ya, mishororo inayojitosheleza kimaana. Hivyo basi, msikilizaji, mwanafunzi, mpenzi wa mashairi ya Kiswahili, nafikiri umeweza kuangalia ukaona kwamba haya mashairi ya kimapokeo, mashairi ya arudhi, mashairi ya jadi yana sifa kama zifuatazo. Yana ule urari wa vina, urari wa mizani katika mishororo, mishororo inakuwa sawa katika beti, pia kuna mishororo kifu au ukitaka mishororo toshelezi. Naomba pia nikupeleke moja kwa moja hadi kwenye sifa za mashairi ambayo ni huru. Pia tuliyaita mapingiti, iwapo unakumbuka pia tukayapa jina kama vile zuhali, masivina au pia ukaita ya kimapinduzi. Sifa za mashairi ya kimapinduzi. Mashairi ya kimapinduzi, mashairi huru. Haya mashairi ambayo ni huru, kama nilivyowaeleza pale hapo awali, ni kwamba malenga wake hajabano na zile kanuni za mashairi ya arudhi, La hasha. Hivyo basi sifa ni kama zifuatazo. Utapata kwamba haya mashairi hayana urari wa vina. Hayana urari wa vina, hayana vina kabisa. Ya? Pia utapata kwamba haya mashairi hayana ule urari wa mizani. Unaweza ukapata kwamba mshororo wa kwanza una mizani 10, mshororo wa pili una mizani 7, mshororo wa tatu una mizani 16 ama 13. Vivyo hivyo. Yaani hakuna ule mpangilio, ya? Aya, pia mishororo si sawa katika beti. Mishororo huwa sio sawa katika beti. Ya? So nafikiri unaweza kupata baadhi ya sifa, na kuna sifa nyingine ambayo ni huwa na mishororo, huwa na mishororo mishata. Huwa na mishororo mishata. Naomba kuliandika hili neno hapa chini kidogo, mishororo mishata. Kidogo naomba kueleza hili neno mishororo mishata. Hili neno mishororo mishata, kama unakumbuka hapo tulipokuwa tukiangalia sifa za mashairi ya jadi, tulisema mishororo yake huwa kifu au ukitaka toshelezi. Basi wacha kidogo nieleze mishororo ambayo inaitwa mishata. Mishororo mishata huwa ni mishororo ambayo haijakamilika kiujumbe. Ni kinyume cha mishororo kifu. Mishororo mishata huwa haijakamilika kiujumbe. Ujumbe wake hukamilika katika mshororo unaofuata. Hata hivyo ninaposema kwamba huwa na mishororo mishata, haimaanishi kwamba shairi zima lina mishororo mishata, la hasha. Ni mmoja kati ya sifa za mashairi ya kimapinduzi ama ukitaka mashairi huru. Kumbuka hapo awali tulikuwa tushasema mambo kuhusiana na kwamba mashairi ya jadi huwa na mishororo kifu au toshelezi. Basi katika hii sehemu nyingine ya mashairi huru kunakuwa na mishororo mishata. Wacha kidogo nieleze hii mishororo mishata ni nini. Wakati ambapo mishororo kifu inakuwa imejitosheleza kiujumbe, hii mingine mishata huwa haijakamilika kiujumbe. Ujumbe wake hukamilika katika mshororo unaofuata. Ya? Nafikiri unaelewa hapo. Yaani ujumbe wake unakamilika katika mshororo unaofuata. Basi na hata kama nimesema kwamba haya mashairi huru au mashairi ya kimapokeo ya kimapinduzi huwa na sifa ya mishororo mishata, haimaanishi ati shairi lote lina mishororo iliyo mishata, la hasha. Inamaanisha tu ni moja kati ya sifa. Utapata tu kuna ile ambayo imejitosheleza, kuna mingine ambayo haijajitosheleza. Ujumbe wake unakamilika katika mishororo inayofuata. Nafikiri hapo mpaka hapo umeweza kutembea nami tangu mwanzo hadi hapa sasa ambapo tumeangalia sifa za mashairi. Mwanzoni tulianzia kwa kueleza kategoria za mashairi au ukitaka aina, ambapo tulisema aina ni mbili kuu. Aina ya kwanza ni mashairi ya jadi au ukitaka arudhi au kimapokeo. Kisha kuna aina ya pili ambayo ni mashairi huru. Pia tukasema yana visawi ambacho ni mapingiti, pia yanaitwa mashairi ya kimapinduzi. Pia utapata yanaitwa mashairi zuhali au masivina na kadhalika. Mashairi ya jadi ya kimapokeo tulisema yanafuata kanuni. kaida au sheria za utunzi wa mashairi, basi malenga wa mashairi haya huwa amefungwa, amebanwa. Lazima kazi yake ipange katika beti. Hiyo ni sheria moja yazo. Lazima kazi yake ahakikishe kwamba mishororo ipo tena imefanana. Mizani yake ni sawa na vina na kibwagizo. Amebanwa na hizo sheria. Huyu mwingine anayetunga mashairi huru hajabanwa kwa vyovyote vile. Yeye anaweza akatunga mashairi yake, bora yafikishe ujumbe, maudhui yawepo, atumie ile lugha ambayo ni teule, maneno yake ayapange kwa namna fulani ambayo itamsaidia yeye kupata ule ujumbe. Basi haya mashairi yanatungwa bila kufuata kanuni au arudhi zile zinazotumika pale. Hatukuachia hapo. Tulienda tukaangalia sifa za mashairi ya jadi, ambapo tulitaja urari wa vina, yanakuwa na ule urari wa mizani katika mishororo. Kuna mishororo ambayo huwa ni sawa katika kila ubeti. Pia mishororo yake huwa ni kifu ama toshelezi. Zaidi tukasema vipi? Kwamba kuna sifa nyingine za mashairi huru, mapingiti ya kimapinduzi, zuhali au na kadhalika. Tukasema vipi? Haya hayana urari wa vina. Si lazima kazi yako kuipanga ati lazima vina viwe vimefanana, la hasha. Pia hayana ule urari wa mizani. Zaidi, mishororo huwa si sawa katika beti. Na pia kunakuwa na matumizi ya mishororo ambayo ni mishata. Hivyo basi, msikilizaji, mwanafunzi, muda wetu unatupa kisogo, na kama nilivyokuwa nimeahidi kwamba nitashughulikia pia bahari za mashairi. Samahani tafadhali kwa ajili ya muda, wacha tupate hayo katika kipindi kingine hapa katika masomo ya mtandaoni ya Manifested. Lakini sitakuacha hivyo msikilizaji, sitakuacha hivyo tu bila kazi ya kufanya. Kazi mradi kwako ni hii. Nataka nikupe swali moja tu ambalo utalishughulikia. Swali lenyewe ni hili. Kazi mradi zieleze kategoria mbili kuu. Zieleze kategoria mbili kuu za mashairi, kisha utolee sifa. Utolee sifa kila moja. Shukran. Kazi hiyo iwe imekamilika katika kipindi kijacho. Asante, siku njema.
Welcome to Manifested Publishers.
Welcome learners. My name is Stephen Kariungi, and today we continue with our topic, genetics in Form 4 biology. And I would like us to discuss how the Punnett square can be applied to solve particular questions. For example, given any situation and then you are told to use the Punnett square, how can you go about applying that to answer a question? So using a Punnett square, to show genetic crossing. And we'll use an example here. So the example is written down here. So we are going to use a Punnett square to show genetic crossing by use of an example. It's a very long question, and these are some of the kind of questions that you expect in a paper 2 setup, where you are given a certain case study, and then you are expected to determine the outcome of that particular case. So we are told that in a breeding experiment, garden peas with axial flowers were crossed with plants with terminal flowers, and then all the F1 plants had axial flowers. So we are crossing the axial flowers with the terminal flowers, but we are getting all had axial flowers. And then when F1 plants were selved is more or less self-pollination, a total of 858 seeds were produced in the F2 generation, out of which 651 gave rise to plants with axial flowers, and of course the remaining ones had the terminal flowers. So using the figures given, work out the ratio of F2 plants with axial flowers to that with terminal flowers. So here we want to find out the solution. Those with axial flowers against those with the terminal flowers. The axial flowers, we are told that we had 651 out of a total of 858. So the remaining ones, 858, if you subtract 651, the remaining ones will be the terminal flowers. So this one will be 87502. So the terminal ones will be 207. So that when you add them, you get 858, which was the total. Then we are told using the figure, work out the ratio with axial flowers and terminal flowers. So that ratio, we should not leave it like that. That ratio, we should not leave it like that. We should get a more simplified ratio, or we should simplify this particular ratio. So to simplify, we divide both sides by 207, so that here we get 1, and here 651 divided by 207, we'll get 3.144 is to 1. So this is approximately a ratio of 3:1. So we should leave that ratio in its simplest form. We should not leave it are 651 and 207. Then B, using a Punnett square to show the genotypes, or use a Punnett square to show the genotypes of F2 offspring, and then we work out the phenotypic ratio. So here we'll get the parental phenotype, that is in F2. So in the F2 we are getting axial flowers versus terminal flowers. Then we go to the parental genotype. So we can say let letter A represent the dominant allele. The dominant allele. Can erase this. The dominant allele. So for axial flowers, we use A, small a, and the terminal ones we use small a, small a. So we had so the terminal flowers, we use the small letters because they are the recessive. Then we come to the gametes. So the gametes have capital A and small a, and these others had small a and there's something I want to confirm, that F1 plants were selved. So the F1 plants were selved. So we are using axio versus axio, not terminal and axio, because we are doing selfing, crossing with one like itself. So axio versus axio. So this will be capital small and capital small. Then from here we draw a Punnett square. So assuming the one was male, the other one was female. So this is that, and the other one was that. So this will be AA, this A small a small a, and small a small a. So in this is the F2 genotype. And then we are told to work out, so to show the genotypes of F2 offspring, which we have done, work out the phenotypic ratio of the F2 phenotypic ratio. So the phenotype of the first one was axio, the second axio, this is axio, and the last one was terminal. So we had 3 axio flowers against 1 terminal flower, and therefore that gives a ratio of 3:1 as we had earlier calculated. So the number that we have calculated must agree with the ratio that we had got here, and that shows that the answer is correct. Name the recessive trait in this cross and then give a reason for your answer. The recessive trait is the terminal flower. The terminal flower is the recessive because in heterozygous state, the flowers are axial. In a heterozygous state, all the flowers are axial or are of axial state. So that shows that the terminal flower is being dominated on by the axial flower. So we are going to have an assignment on that. So the first question, what is heterozygous state? B, homozygous state, and C, recessive allele, as we have explained them. And then number 2, what is selfing? So you'll answer those questions based on what we have already discussed. So we'll stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform, a chemistry lesson. If you remember in the previous lesson, we discussed, or we first of all came up with the objectives which you need to achieve by the end of this chapter. And also we defined 2 important terms which we will be using throughout in this chapter. We talked about law and gas, where we say that a gas is a physical state of matter with a definite mass, with a definite volume, with an indefinite volume and indefinite shape. And the law, we said that it is a fact, it is a statement of fact which is coming from an observation, from an experiment you've done on natural or scientific phenomenon which occurs due to changes in some conditions, which again we are going to discuss them further in this topic. In our today's lesson, we will start with Boyle's law, because we talked about the 4 laws, which were Boyle's law, Charles' law, combined gas law, and Graham's law of diffusion. So we start with the first law, which is Boyle's law. So this law was named after a scientist called Robert Boyle. So Robert Boyle was the name of the person who came up with this law, Boyle's law. I want to define this law. Definition. In Boyle's law, state that the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. It states that the volume of a given mass of a gas is inversely proportional to pressure, and temperature must always be constant. The volume of a given mass of a gas is inversely proportional to pressure at constant temperature. I want to simplify it further for you and explain it and say, when we say it is inversely proportional, when we say that the volume of a given mass of a gas is inversely proportional, we mean that when volume, well, this means that when volume of a gas increases, the pressure of the gas decreases. The volume of a gas increases, the pressure of the gas decreases. And when pressure of a gas increases, the volume of the gas decreases. The volume of the gas decreases. When volume of a gas increases, the pressure of the gas decreases, and when the pressure of the gas increases, the volume of the gas decreases. That is the simple way of understanding Boyle's law, that when the volume is high, pressure is low, and when pressure is high, volume is low. I can use this example to explain it to you simply or in a simple way. I can use a small container in my container. I have this is just a tube. This is the piston. Inside my tube, there is air inside. So there are particles of air which are inside my tube. When I press this piston downwards, it means, one, the volume decreases. So the volume will go down. The volume of the air particles inside my tube will decrease. And at the same time, pressure increases. I know you're wondering how pressure increases. I will explain it to you. The reason why pressure is increasing is because when you press this piston downwards, the volume decreases. And at the same time, the pressure is increasing because the particles, they are now closer to one another. The particles of this air inside this tube becomes closer to each other, meaning that there is more collisions between these particles themselves. There's more collisions between these particles of this air inside within themselves and also within the walls of this tube. That is what is causing the pressure to increase. So anytime volume decreases, pressure increases. Pressure increases when volume decreases. I hope you get that clearly. At the same time, I want you to imagine if you pull this piston upwards. If you pull this piston upwards, this what means is that the volume inside, because now this the volume inside will increase. The volume of air inside the tube will increase. And the pressure will decrease. And the reason why pressure will decrease is because the particles, they now move far apart from one another. The particles of air move far apart from one another. When they move far apart from one another, then there is the effective collisions or the probability of these particles colliding with one another and also with the walls of the tube decreases. And that's how the pressure decreases when volume increases. I hope you also understand that very clearly, because our Boyle's law, we have said that when the volume of a given mass of a gas or the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. So temperature always must be constant. So temperature must remain constant at all times. For example, the room temperature, we take the room temperature to be 25 degrees Celsius or 298 Kelvin. That is a constant temperature. So at all time, temperature must be kept constant. There is no variation in temperature. Understand that very well. I will use a live example, and I will use one of my simple apparatus I have. This one is called a dropper. This dropper is having a volume of air inside. There's some air inside this dropper. What happens when I press the upper part? What do you think happens to the volume? The volume is decreasing. And the pressure inside, or the pressure of the particles inside, is increasing. Now to demonstrate that, maybe you can put the dropper on your finger and now press the upper part. When I press the upper part, there's some force exerted on my finger. There's some force exerted on my finger, means that the volume of air inside now is getting its way out, or is trying to get its way outside this dropper, because volume has decreased and pressure, volume has decreased and pressure has increased. That's why that high pressure is now forcing my finger, so that the air can get out. That is a simple demonstration. So it shows that when you decrease volume, pressure increases. And that's why there's some force exerted on my finger. Get that clearly. At the same time, if you release, then it will have, the dropper will have the original shape of the dropper. So there is some air inside at the same time, and there's also pressure, which is inside, because pressure cannot be zero and volume cannot be zero. You cannot have volume of air having zero pressure, and you cannot have pressure when there is no volume again. So volume and pressure cannot be zero. Maybe now to demonstrate it further using a graphical representation, I can draw a simple graph again to explain it to you how when volume increases, pressure decreases, and when pressure increases, volume decreases. I will draw a simple graph to demonstrate that. So this is our y-axis and the x-axis. So this is a graph of pressure against volume. So when you're drawing a graph of pressure against volume, then pressure should be on the y-axis. So we have pressure, which is pressure P, and volume, you have volume V. Now to demonstrate this Boyle's law, then the curve will look like this. That is a curve. Then suppose we have some calibrations, though this ours is not drawn to scale. If you have 0, 10, 20, 30, 40, our scale, and also on the y-axis you have 10, 20, 30, 40, 50, like that. It means that, let's take an example of where the pressure of a gas is at 40. The pressure of a gas is at 40, and at the same time, the volume of this gas is at 10. Pressure is at 40, the volume at 10. Let's take when the volume of this gas is 10, sorry, when the pressure of this gas is 10, we see what the pressure will be. So that is kind of the pressure which will be present. So you see that the pressure is around, let's say it's something like to do with 23 pressure. So this shows you that when the pressure is high, volume will be low. That's why we have the pressure is 40, the volume is 10. And this time we have pressure being 10, the volume has increased. That is the same way I've explained in this one, that if you press the piston downwards, the volume will reduce and the pressure will rise, because the particles of this air inside the tube is colliding more within themselves, those particles, and with the walls of the container. And when you pull it upwards, the volume in the tube increases and the pressure decreases, because the particles inside, they don't collide more because they are far apart from one another. I hope you understand that very well. So you can explain it using the piston, and also I've used a simple graph to explain the Boyle's law. So this is a graph of pressure against volume to demonstrate Boyle's law. Demonstrate Boyle's law. That is what I wanted you to understand in this lesson. But as I finish, I've said that this law was named after a scientist known as Robert Boyle. And we define this Boyle's law as that the volume of a given mass of a gas, the volume of a given mass of a gas is inversely proportional to pressure at constant temperature. So temperature always must be constant. And the simple way of illustrating this, I've said that when volume increases, then you expect the pressure of the gas inside a certain container or a certain vessel to increase. When the volume increases, you expect the pressure, to decrease. And when pressure increases, then you expect the volume to decrease in that container or in that vessel. Then I've used a simple example of demonstrating that using a container or a tube which is having a piston. And I've seen that when you press the piston downwards, the volume inside decreases and the pressure will increase because there are effective collisions, that the particles of this air inside the tube collide more with one another and also with the walls of that tube. And that's why the pressure is increasing. And at the same time, if you pull the piston upwards, the volume inside the tube will increase and the pressure will decrease. And the reason why the pressure is decreasing is because the gas particles or the volume of air inside the tube, the particles are far apart from one another. So the particles are not colliding more fast or move vigorously, and that's why the pressure decreases. That is a simple way of demonstrating Boyle's law. Otherwise, that's the part of our lesson today, and I will leave you with this assignment. And the assignment is I'll give you one question only. Is define Boyle's law. Define Boyle's law. I have defined it for you, so try and see whether you can be able to remember what we have discussed. Thank you for participating in the lesson. See you in the next lesson. Bye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. We continue with our topic of discussion. The topic is nitrogen and its compounds. And today we are discussing more chemical properties of ammonia. So we are going to discuss chemical property number 3. And this is the reaction of ammonia gas with air. And basically we can say that ammonia does not burn in air. Ammonia does not burn in the presence of oxygen in the air. But however, if that oxygen in the air is enriched, or if air is enriched with more oxygen, then ammonia burns with a green-yellow flame. So we are saying that ammonia does not react with oxygen in the air. However, when air is enriched with oxygen, of course from an external source, when the air is enriched with oxygen, ammonia burns with a green yellow flame, a green yellow flame, and this leads to the formation of nitrogen and water. So if the ammonia gas reacts with air that is enriched with oxygen, so we are talking about excess oxygen, then you are saying that it will be oxidized to nitrogen gas and water. So in that case, we can balance the nitrogen. The hydrogen will be 6. So we put 3. These are 2. We make this to be, no, make this to be 6. 6. Hydrogen 12. So we can counter check for 12, 12, 6, 6. So that equation can be simplified. That is 2, 3, 3. That is a problem. Let's balance again. So the oxygen here, there are 2. That makes hydrogen 4. Nitrogen, hydrogen, there are 6. So 3, 6, 6, 2, 2, oxygen 3, 5 times 2, that is 3. Six. Yeah, so it's supposed to balance like that. So we are saying that ammonia reacts with oxygen or with air that is enriched with oxygen to form nitrogen and water. So that is the reaction with the air. And we can say that in the presence of platinum catalyst, ammonia reacts faster Ammonia reacts faster with a highly exothermic reaction that makes the platinum wire to glow. So in this case, platinum acts as a catalyst. So to make the reaction between ammonia and oxygen faster, we use a platinum catalyst. And we are saying that the reaction is highly exothermic. It produces a lot of heat, and that heat makes the platinum wire to glow. And here, nitrogen 2 oxide and water are produced. So here what we are saying is that the same ammonia gas plus oxygen, but now in the presence of platinum, a platinum wire as a catalyst, then ammonia is oxidized to nitrogen 2 oxide plus water. So this shows a further oxidation. So you're saying that the reaction is faster because of the platinum wire catalyst. To balance the equation, nitrogen is okay, oxygen is okay, hydrogen there are 2, and here there are 3. So if you put a 2 here, there are 6, and if you put a 3 here, we balance the hydrogen. However, the oxygen will be 4, and therefore also we need to balance that, and nitrogen also will be 4, no, will be 2, and then oxygen will be 5. Here there will be 4, so we multiply this one by 5, here by 4. So 4 nitrogen, 12 hydrogen, and 10 oxygen. So that equation is balanced. So that is the reaction of ammonia with air without a catalyst and in the presence of platinum wire catalyst, where the reaction is faster. Number 4, we have the reduction properties of ammonia gas, and we can see that ammonia gas is a reducing agent. Is a reducing agent because it reduces heated copper 2 oxide to copper metal, as can be seen in this equation. So we are saying that ammonia gas passed overheated copper 2 oxide, and you'll find that copper 2 oxide will be reduced to copper metal, plus the hydrogen will be oxidized to water, plus nitrogen gas. So the diagram for that, So the diagram here shows ammonia gas pass through heated copper 2 oxide, and what happens is that ammonia reduces copper 2 oxide to copper metal. There is formation of water, so there is a colorless liquid which is water that collects in the U-tube. Then nitrogen gas is collected over water as shown in the diagram. So this is the reduction property of ammonia gas. So ammonia is a reducing agent in this setup. So it reduces copper 2 oxide to copper. So here the color changes from black to red brown, and that is because of reduction of copper 2 oxide to copper. Water is condensed by the ice salt mixture. The ice salt mixture condenses the water, and then nitrogen gas is collected in the gas jar over water. So to balance this equation, we say that the equation should always be balanced. So nitrogen we balance, hydrogen there are 2, here there are 6, so that makes 6 as well. Oxygen there are 3, here we should have 3, and copper they should also be 3. So 2 nitrogen, 6 hydrogen, 3 oxygen, and 3 copper. So that equation is balanced. Our assignment, so the first question in the assignment, write a balanced chemical equation between ammonia and copper 2 oxide, and 2, in the above equation, name the oxidizing agent. Which is the oxidizing agent in that equation? So we are going to stop there. Until next time, goodbye.
Hello learners, welcome to today's lesson, solving problem in waves 1. Here I have the questions which I would like to take you through. The first question, it is written, a water wave traveled 12 meters in 4 seconds. If the frequency of the wave is 2 hertz, calculate A, the speed of the wave, B, the wavelength of the wave. So here we have solution. What we have in our question here is distance, which is 12. So 1, so we have distance, which is 12 meters. Then we have time, seconds, time 4 seconds. So part A, we are being asked to determine the speed of the wave. Speed of the wave. So speed generally is just given by the distance covered, then out of or divided by time taken. So I want to find the speed of the wave. I will have the distance covered, then divide it by time taken. This gives us distance is 12 meters, then time is 4 seconds. So if I take 12 divided by 4, it will give me 3 meters per second. This is the speed of the wave. This is the speed of the wave. So by listing these parameters, I've realized I've forgotten to list this frequency. So frequency, I've also been given frequency F, which is 2 hertz. Now part B, they are asking us to determine the wavelength of a wave. But generally, from the relationship between wavelength, speed, and frequency, we always say that speed is given by frequency then times lambda. Here, V represents speed, F is frequency, and lambda is wavelength. So we are being asked to calculate wavelength, which is lambda. Now from my formula here, it simply means that if I want to get wavelength, then I divide both sides by F, frequency. So my wavelength lambda is equal to speed, then divided by frequency. Now we have speed, my speed is here, then my frequency is here, which is 2. So I substitute in my equation. So this one gives me speed, which is 3 meters per second, then divided by frequency, which is 2 hertz. So this one, it will give me 1.5 meters. Remember, the units of measurement of wavelength, it is measured in meters. So that is why it has given me that one. This is the working for question 1. Now for question 2, we have the diagram. The figure below shows a displacement time graph for a progressive wave. So we have here a graph, displacement against time. So we have -10, then we have 10, then we have 10, 20, 30. Time is expressed in second, displacement is expressed in meters. So the first part, we are being asked to state the amplitude of the wave. So this is question 2. Then Roman 1. When you were discussing these characteristics of a wave, we said that amplitude is the maximum displacement of a wave from the mean position. So if it is the maximum displacement, then this one, it represents our mean position is the x-axis. So maximum displacement, it can be upward or downward. Now from our diagram here, or from the graph, the maximum displacement this is amplitude, is 10 meters. Maximum displacement from the mean position. This is my mean position. And remember, this equation, if I have it like this, so this is the maximum displacement, expressed in meters. Now this one represents displacement is a vector quantity. It can be negative or positive, but we shall consider that one of positive. So from the graph, our displacement or amplitude is 10 meters. Then Roman 2, we are being asked to determine the frequency of a wave. The frequency. When you are discussing these characteristics, we said that frequency is the number of complete oscillations made by a particle in 1 second. From this diagram, when I want to make one complete oscillation for this wave, then I must have a crest and a trough. This is a crest, then this is a trough. Then you realize that this is a half of the trough. Now, from the diagram, this simply means that a complete wave, it will end at this point where time is 20 seconds. Because this is a quarter, when I add another quarter, then I have a half. This is a complete one. So meaning that a quarter of this plus a quarter of this, it will make this one to be a complete oscillation. So we always say that frequency, number of complete oscillation made by a particle within 1 second. Now, within 1 second. Now, our key term here is 1 second. So I may say that this is the time. One complete oscillation, one oscillation is given by 20 seconds. So what about 1 second? That is my now frequency. What about 1 second? Now from there, I cross multiply. I have 1 times 1, then divide by 20. This is giving me 1 over 20. In terms of decimal places, I may have 1 divided by 20 is equal to 0.005. 0.0, that is frequency hertz. Then for Roman 3, determine the period of the wave. Roman 3. Period T, we said this one, the relationship between period and frequency is that T is equals to 1 over F. 1 over F. This F represents frequency. And I have calculated, I have here frequency. Meaning that if I want to calculate period, then I just substitute in the value of F. That is 1 over 0.05. So if I substitute in, I have 1 divided by 0.05. It gives me 20 seconds. That is the period. Then Roman 4, given that the velocity of a wave is 200 meters per second, determine its wavelength. I have said from the first question, the relationship between wavelength, speed, and frequency is that V is given by frequency, then multiply by lambda. This lambda is wavelength. So we are being asked to determine that wavelength. This means that my lambda is equals to speed over frequency. Speed over frequency. Remember, we have our speed, it is 200. Then our frequency, it is here, 0.05. So we just substitute in. We have our speed 200. This 200 divided by 0.05. So 200 divided by, that is 200 divided by 0.05. 0.05, it gives me 4,000 meters. It is giving me 4,000 meters. So this is the calculation or the solution for question 2. The amplitude is 10. We have frequency is 0.05. Period is 20. Then our wavelength is 400 meters. Now let us move to question 3. Move to question 3. For question 3, we have also been given, this is question 3, we have frequency f 3 times 10 raised to 6 hertz. Then we have our speed v equals to 3 times 10 raised to 8 meters per second. So we are being asked to determine the wavelength. From our previous questions, we have been able to simplify these wavelengths. And we have said that wavelength is just equals to speed then divided by frequency. Meaning that I just substitute in, we have speed 3 times 10 raised to 8 meters per second, then divide by 3 times 10 raised to 6. This is hertz. So if I divide this, it will give me 100 wavelength, which is meters. So this is the working for question 3. Working for question 3, the solution for the first 3 questions. So I would like to give you an assignment that you can try when you are at home. So these are the 3 questions that I would like you to try, to attempt. The first question, a rope is displaced at a frequency of 3 hertz. If the distance between the 2 successive crests of the wave train is 0.8 meters, calculate the speed along the rope. Question 2, the figure below illustrates parts of the displacement time graph of a wave traveling across water at a particular place with a velocity of 2 meters per second. Calculate the wave's amplitude, B, frequency, C, wavelength. So this is the diagram. Then C, that is question 3, distinguish between longitudinal and transverse wave. These are the questions that I would like you to try. Not just trying, but attempt. And you'll realize that they are very simple. That marks the end of our lesson of today. We shall meet tomorrow. God bless you and bye-bye.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi. I am presenting to you a topic in Form 1 biology, and the topic is cell physiology, as indicated here. First of all, I would want us to go through the objectives of this topic. So we look at chapter objectives. The first one, we need to understand what is cell physiology. So we need to understand the meaning of cell physiology. Number two, we should also be in a position to relate the cell physiology and the structure of the cell membrane. So the other objective is to be able to relate the process with the semi-permeability of cell membrane. Number three, we'll also be able to state the meaning of three physiological processes. These are diffusion, osmosis, and active transport. So, be able to state the meaning So you'll be able to state the meaning of those three terms, the term diffusion, osmosis, and active transport. Objective number 4, we'll be able to study the factors that affect these three processes, the factors that affect diffusion, osmosis, and active transport. So that is objective number 4. Then we go to objective number 5. We should also be in a position by the end of the topic to describe some of the experiments that one can carry out to investigate diffusion, osmosis, and active transport. So we should be able to describe experiments to investigate the above processes. And finally, the objective number 6, we should be able to distinguish between Turgor and plasmolysis. Those are two terms that we'll also be learning in the course of the topic, and we should be able to distinguish them. So those are the objectives that we shall be fulfilling in the study of the topic cell physiology. So from there, we'll embark on an introduction, and we want to understand what is the meaning of the word cell physiology. As the word suggests, it has something to do with the cell. And the fact that it ends with a logy, it means that it is a study. So in this case, in cell physiology, we study the cell functions. So in this case, we shall look at the various structures that are found within the cell and how they carry out their functions. So we will say that cell physiology is the study of cell functions. And of course, in a cell, we know that we have different structures. We have the cell membrane, we have the mitochondria, we have the chloroplasts if it is a plant cell. So we need to understand how those structures function within the cell. So basically, we shall be dealing with cell physiology. Now, a very important aspect of cell physiology that we also need to look at is the structure of cell membrane. We need to look at the structure of the cell membrane, because before something gets into the cell or out of the cell, it has to go through the cell membrane. So the cell membrane is a membrane or a layer that is made up of two things. Is made up of something that is called a phospholipid and a protein layer. So it's made of two layers, i.e. phospholipid. I'll explain what is a phospholipid and a protein. So it's made up of those two layers. A phospholipid is a fat layer. Anything that ends with the word lipid, it means that it's either a fat or an oil layer. Then, of course, the other one is a protein layer. So what we are basically going to do, we are going to have a diagram showing the cell membrane and how it looks like. So the cell membrane looks like that. First of all, there is the first layer, assuming that this is the outside and this is the inside. So this first layer is the phospholipid. Layer, and then the one that is marked using a different color, that is red, that is the protein layer. So basically we are saying that a cell membrane is made of a phospholipid layer or a fat layer and a protein layer. Now, in between the protein layer, there is a small opening here, and that opening we call it the pore, P-O-R-E. It's a hole that allows substances to get inside the cell and also outside the cell. So that opening is meant for that. We shall look at the characteristics of the cell membrane. So this is basically the cell membrane structure, which we have said is made up of two layers. There is a phospholipid layer on either side, then there is the protein layer in between. There is a protein layer in between. So it doesn't have to be in one position. It can be in a number of positions. But basically, there is the phospholipid layer and there is the protein layer. Then in between the protein layer, there is a pore, or there is a hole that allows materials to get in or out of the cell through the cell membrane. And then the other thing that I want us to look at are the properties of the cell membrane. We look at the properties of cell membrane. One, we say that the cell membrane is semi-permeable. The cell membrane has what is called semi-permeability. And that means that it allows only the small molecules to pass through but not large ones. So it's only allowing the small molecules to pass through the pore. Yeah, those, if molecules are small enough to fit the pore, they can pass through in and out. But if the molecules are large, they cannot pass. So we say that the cell membrane is semi-permeable, or we can say it's selectively permeable. So you can also stroke that with selectively permeable. It means the same thing. Now, characteristic number 2 is that the cell membrane is sensitive to temperature and pH. It's sensitive to temperature and pH. And the reason for that is because the protein layer and the lipid layer, they are sensitive. Yeah? If the temperature is too high, then the cell membrane is affected. If the temperature is also too low, it's also affected. Same case applies to the pH. So pH is the degree of acidity or alkalinity. So it's sensitive to temperature and pH. And lastly, number 3, the cell membrane is polarized. Polarized means that it has charges. It has charges that are positive and negative. Has charges that are positive and negative. So basically, we have looked at the objectives of the entire topic. We have listed them down. Then we have gone ahead and defined what is cell physiology as the study of cell functions. We have looked at the structure of the cell membrane, and we have seen that the cell membrane is made of 2 layers. There is the phospholipid layer and there is the protein layer. And then we have also said that in the protein layer, there is a pore that allows materials to get in and out. Then we have looked at the properties, 3 properties of the cell membrane. One is its semi-permeability or selectively permeable, meaning that it is selective. It selects the small molecules to go through, but not the large ones. It's also sensitive to changes in temperature and also pH. And finally, the cell membrane is polarized. That means that it has both positive and negative charges. So our lesson for today will end there. Then we'll have an assignment based on what we have learned. So the first question, we define the term cell physiology as we have learnt it. 2, we describe the structure of cell membrane, description of that structure. And then number 3, we state 3 properties of cell membrane. So we are going to stop there for today, and we shall continue from there next time. Goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and today we continue with our topic of discussion, and this is on genetics. So today we are going to discuss inheritance of ABO blood groups. When it comes to the blood groups, you find that we have 4 blood groups. We have blood group A, we have blood group B, blood group AB, and blood group O. Now, blood group A and B are as a result of the presence of gene A for blood group A and gene B for blood group B. Now, where there is the existence of the gene for blood group A together with the gene for blood group B, we get a blood group AB. We get a blood group AB. And therefore, we can say that the gene for blood group A and the gene for blood group B are codominant. They are codominant. Codominant means that they both express themselves if they are to come together. For example, this is the gene for A, this is the gene for B. When they come together, we get blood group AB. So we are saying that blood group A is as a result of gene A, which is responsible for antigen A. Antigens are written using capital letters. So a person has blood group A because of gene A. And that gene A is the one that causes the presence of antigen A. Then the same applies to blood group B. Is as a result of gene B, which is responsible for antigen B. As again repeated, antigens are put in capital letters. Then we have blood group O is as a result of gene O. There is gene O, which is responsible for no antigens. Which is responsible for no antigens. So O means that it's like it's zero antigens. So when the gene O is there, then the blood group is O and means that there is 0 antigens. Now, when gene A and B occur together, we get blood group AB due to the presence of antigens A and B. So when there is gene A and B together, we get blood group AB, which is as a result of antigens A and B. So, or therefore, gene A and B are said to be codominant, which means equally dominant, which means that they are equally dominant, or both express themselves, in the trait. So codominant or codominance means that a situation whereby we have two genes that are both expressing themselves. They are equally dominant. It's like they have equal strength. So if you have blood group A, you have gene A. You have blood group B, you have gene B. When the two come together, you get blood group AB. So both gene A and gene B is expressing itself in the trait of the blood group. So in this case, we are saying that they are equally dominant or both express themselves in the trait. Now, however, gene O is recessive. Gene O is recessive and can only express itself. It can only express itself in the absence of either gene A or B. So the only time that O expresses itself is when the A and B are absent. Otherwise, if A is present, we get blood group A, even when O is there. When B is present in the together with O, we get blood group B. So O can only express itself in the absence of either A and B. That's why we are saying that it's a recessive. It's a recessive gene. We'll summarize that as a table. So we have the blood group. Then we have the blood group is the same as the phenotype. So the blood group is the phenotype in this case. Then we have the genotype. Then we have the antigens. So we have blood group A. The genotype can either be AA, that is where we have the two genes or the two alleles for blood group A, or AO, because O is always recessive in the presence of A. So O cannot express itself here. So this person is blood group A heterozygous and A homozygous. So this person has antigen A. A person with blood group B, the genotype is BB or BO. Remember, O is recessive. The antigens present B. A person with blood group AB, which is codominant, equally dominant, the genotype is AB, because there is the existence of both gene A and B. So the antigens A and B are present. So we have that table. Blood group O, that is phenotype O. Remember, the phenotype is the blood group as indicated. The genotype of O can only be OO. So where there is either A or B, we cannot have blood group O. And this one has no antigens. There is none of the antigens. So this is a summary of the ABO blood groups. Summary. So the next, we'll have an exercise on that. So we have two questions there, and we are told that a person has blood group AB. Then you are told to name the antigens that are present in that blood group. And B, explain why the person is a universal recipient. Explain why the person is a universal recipient. Number 2, distinguish between codominance that we have just learned and incomplete dominance learned earlier. So we are going to stop there. Until next time, goodbye.
Hello learners, today we will still continue with the topic angle properties of a circle. So I'm going to solve the question I'd given you, number 5, from secondary mathematics, exercise 19.1, number 5. So I'll read the question. In the figure below, O is the center of the circle, Ln and Pm are diameters. Show that Lm is parallel to Pn. So I'll write the question on the board. The question on the board, I read, in the figure below, O is the center of the circle. Ln and Pm are the diameters. Show that Lm and PLM, show that Lm is parallel to Pn. So to solve that question, there are concepts you must have. Number 1, when they talk of diameters, there are 2 diameters there, Ln and Pm. From the previous concepts, we had seen that a diameter will subtend a right angle in any of the segments. So let us look at the diagram and see some of the angles the diameters will subtend. Because from the question, before you prove it, a parallel line, 2 parallel lines, a perpendicular drawn from a point on one of the line should meet the other line at 90 degrees. So if we are able to identify some of those angles, they'll be able to help us to prove that. So let's see some of the angles formed in that. So let's start with diameter Ln. Diameter Ln. We want to see whether there is any right angle it is subtending. So if I prolong that and got that small chord there, I will already get a right angle there. It is a true proof that angle LMN is a right angle because it is subtended by which chord? Ln, which is the diameter. Therefore, angle LMN is equals to 90 degrees, which is a right angle. We get, let's find other angles also. Let's consider also chord diameter PM. Diameter PM. If we prolong this chord L to P, we'll find that diameter PO, diameter PM will subtend angle MLP, which will also be a right angle. So it goes without saying that angle MLP is equal to 90 degrees. We are not done yet. There are two more right angles we'll get. There are two more right angles we'll get. So we've got angle LMN, and we've got angle MLP. We can also get angle LPN, which is a right angle because it is subtended by chord LN. A diameter subtends a right angle on any point on the circumference. So it goes without saying that angle LPN, angle LPN is equal to 90 degrees. Reason, it is subtended by the diameter. We go to the last fourth angle, which is angle MNP. Angle MNP. It is subtended by diameter PM. You can easily see this is the diameter. It is subtending this angle in that segment. So it goes without saying that angle MNP is how many degrees? 90 degrees. We've got all those concepts from the diameters subtending angles in any of the segment. The angles will be 90 degrees. So we go back to the question where we are sure that these lines LM is parallel to PN. Number one, for lines to be parallel, a line drawn, a perpendicular drawn from one line to go and touch the other line, it will strike it at 90 degrees. It has to strike that other line at 90 degrees. So we'll go back to the diagram and see, does that happen? We have line L, M, and PN, which are the lines in question, which we have to prove they are parallel. Isn't it? So let's go to the lines. This is line LM. When I have a right angle here, it shows that MN acts as a perpendicular. MN acts as a perpendicular. And that perpendicular goes to strike line PN at what angle? You can see it is 90 degrees. That is only one end, isn't it? So if you prove it on one end, it is already a true proof, but we have still to get the other angles. Let's move to these other points. We have LP, which is acting as a perpendicular because it is line LP is meeting line LM at 90 degrees. And it is also meeting line PN at what degrees? At 90 degrees. That is a sure proof that the two lines are parallel. So to get to the proof, we say we now have LP and MN will act as a perpendicular. So for lines to be parallel, parallel are perpendicular drawn from one line should meet the other line at 90 degrees. So let's go to our diagram and see, does that happen? LP and MN are acting as our perpendiculars, isn't it? So perpendicular, when you say perpendicular LP, it is rising from which line? Line LM. And it goes to meet line PN at 90 degrees. So you simply say perpendiculars they have acquired a name, perpendiculars. Perpendicular LP and MN from line LM meets line PN. They meet line PN, you can see, at line PN at 90 degrees. Therefore, line LM is parallel to line PN. That is a direct proof that the two lines are parallel, because the two perpendiculars drawn from one line go to meet the other line at 90 degrees. That is just one of the methods. The other method, there is an angle given there, x. That angle could lead us to having another alternative solution of proving that the lines are parallel. So we have an alternative solution. We have an alternative. So in the alternative solution which we have, I'll have to draw a diagram that will help us to solve that question. So that is our diagram, and we had an angle here, x, which is going to help us in the proof. So if we have a diagram, in the first one we used the perpendiculars. So you realize two parallel lines. If we have two parallel lines, if we have a vertex drawn from one line to go and cut the other line, it will form a pair of alternate angles which should be equal. So let's look at our diagram and see how that will come about. We have line LM and PN. MP is a line right from line LM going to cut line PN at point P. So if the lines are parallel, isn't it? So if the lines are parallel, the value of this angle, I can just use A degrees will be equal to B degrees. So I say parallel lines form a pair of alternate angles which are equal. In our question, the angles in questions, we are talking of if X will help us to get the value of A and B, then we find they are equal, then the lines are parallel. If LM is parallel to PN, angle A will be equal to angle B. So having that, I have to calculate the value of angle A and also the value of angle B. And then I compare their values. If their values are equal, the lines will be parallel. So let's go to the length of finding the value of angle A. So we go back to the diagram. That is a straight line. This is angle A. It is arising from an isosceles. So from the isosceles triangle, we find in an isosceles triangle, we have a pair in the isosceles triangle. The two values should be equal. So if we have OPN as A, we shall have ONP as A degrees. So there is another angle in the isosceles triangle which we've not got, but X will help us to get that angle. That angle is PON. And given that X added to that angle gives 180, therefore the value of PON will be 180 minus X degrees. So we'll go back to a concept that the three angles in a triangle add up to 180 degrees. So therefore A plus A plus 180 minus X should give us 180 degrees because there are three angles in a triangle. So from that equation, we shall get the value of X. So we continue. A plus A, 2, we'll get 2A plus 180 2A plus 180 minus X is equal to 180. So since I'm only interested in X, I'm only interested to get the value of A. I'm interested in to get the value of A. So I'll leave it on the left hand side of the equation. So I'll have, the other ones will go the other side. So I'll have 2A. When this one goes, the other side becomes a negative, it's a positive. So we'll have 2A is equal to 180. Take it the other side, becomes minus 180. This is a negative. Take it the other side of the equation, it becomes a positive. So moving down, we shall have 2A is equal to 180 minus 180, you get 0. Then you remain with x. So from that, the value of, to get the value of A, I'll divide 2 on both sides. So A will be equal to x divided by 2. That will be the value of A. I've already got the value of A. My next step will be getting the value of B to ascertain whether it is equal to A, because the series of alternate angles I was talking of were A and B. So I'll go back to that diagram. Given that PON is 180 minus X, it is directly opposite to LOM. So directly opposite angles are equal. So this angle will be what? 180 minus X. And since this one is also isosceles, this value of angle MLO will be B degrees. B degrees. So right from what I did here, it will also be therefore, from the diagram, B plus B. B plus B plus 180 minus X. It will give us 180 degrees, because those are 3 angles in a triangle. So let's move ahead with the equation. B plus B, 2B plus 180 minus X should give us 180 degrees. So I'm interested in B. So B will remain on the left-hand side of the equation. So we move ahead by saying 2B is equal to, you take 180 the other side, it becomes 180 minus 180 plus, X now becomes plus. So 180 minus 180 is 0. Therefore, 2B is equal to X. Therefore, B is equal to X divided by 2. So you find that the value of A is equal to B. So you write A is equal to X divided by 2 degrees, and B is equal to X divided by 2. Therefore, A is equal to B, and therefore line LM is parallel to line is parallel to line PN. So that is a proof that the two lines are parallel, because we found out that the pair of alternate angles they are forming, it will always happen in when two lines are parallel. A is equal to B, and the two lines, the two angles are alternate and equal, and we have proved the value is x divided by 2. So that is the alternative solution, which we worked using the value of angle x. We've come to the end of the lesson today, so I'll give you an assignment from the learner's book. The assignment. Thank you. That's what we'll do for the assignment. See you in the next lesson.
Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Hujambo mwanafunzi, karibu katika Manifested online classes, ambapo leo hii mimi Mugambi James nitakufundisha Kiswahili, na leo hii tunataka kushughulikia ushairi. Kwanza katika hiki kipindi chetu tunafaa tuangalie kufikia mwisho wa hiki kipindi tuweze kujua maana ya ushairi, maana ya shairi, kisha tuangalie baadhi ya istilahi ambazo zinatumika katika ushairi ama katika huu uwanja wa ushairi katika mashairi. Hivyo basi Kiswahili siku ya leo mada yetu leo ni ushairi. Kwanza tujiulize, shairi ni nini? Shairi ni nini? Shairi. Kuna vitabu mbalimbali ambavyo vimegusia mambo kuhusiana na maana ya ushairi. Hawatofautiani wote. Wanaeleza kwamba shairi ni utungo wa kisanaa ambao unatumia lugha teule na mpangilio maalum wa maneno kwa ajili ya kuwasilisha ujumbe. Na ukisikia katika hayo maelezo nimesema vipi? Nimetaja mambo kuhusiana na utungo wa kisanaa. Shairi ni utungo wa kisanaa. Huu utungo wa kisanaa unatumia lugha teule. Huu utungo wa kisanaa unatumia lugha teule. Mbali na kutumia lugha teule, una mpangilio maalum wa maneno. Kwa sababu gani? Kwa ajili ya kuwasilisha ujumbe. Hivyo basi katika maelezo yako, katika kufafanua ama kueleza dhana ya ushairi, katika kueleza dhana ya shairi, eleza kwamba ni utungo wa kisanaa unaotumia lugha teule na mpangilio maalum wa maneno kwa ajili ya kuwasilisha ujumbe. Lengo la kwanza limekamilika. Wacha tuangalie lengo la pili, ambapo ni kuangalia baadhi ya istilahi zinazotumika katika ushairi. Istilahi katika ushairi. Istilahi katika ushairi. Ninapotumia neno istilahi hapa, namaanisha baadhi ya maneno yanayotumika ama msamiati unaotumika katika mashairi. Kwanza kabisa, wacha tutumie neno mshororo. Tuzungumzie mambo kuhusiana na mshororo. Mshororo ni nini? Mshororo ni mstari. Ni mstari wa maneno. Ni mstari wa maneno katika shairi. Yaani tuseme katika shairi kunakuwa na vifungu mbalimbali vya hii mistari. Mistari miwili mitatu inaunda kifungu kimoja. Mistari mitatu tena inaunda kifungu kingine. Hivyo basi hiyo mistari katika shairi ndio ambayo tunaita mshororo. Hii mishororo inaweza ikaungana miwili mitatu minne ikaunda ubeti. Nimesema vipi? Kwamba mishororo miwili mitatu minne mitano ikaunganishwa pamoja inaunda kitu ambacho tunaita ubeti. Hivyo basi ubeti maana yake ni kama ushaifahamu, ni kifungu cha mishororo kadhaa. Ni kifungu cha mishororo kadhaa. Ni kifungu cha mishororo kadhaa. Huo ndio ubeti. Mbali na ubeti, wacha tuende kwenye istilahi nyingine ambayo ni kipande. Kipande. Utapata kwamba katika baadhi ya mashairi mishororo huwa imegawanyishwa kuwili ama mara tatu ama mara nne. Ya, unaona vipi? Yaani kunakuwa mshororo mmoja unakuwa na kipande kimoja, cha pili, cha tatu na mara nyingine hata cha nne. Hivyo ndivyo ambavyo tunaita vipande. Hivyo basi kipande ni kisehemu katika mshororo. Ni kisehemu katika mshororo. Ni kisehemu katika mshororo. Nafikiri naweza nikachora tu kidogo hivi kwa ajili yako wewe mwanafunzi kuelewa. Yaani tulisema kwamba mshororo ni mstari wa maneno. Ya, unakuwa na mstari namna hii. Lakini mstari wenyewe unakuwa umegawika. Katika baadhi ya mashairi unapata kwamba mshororo unakuwa na vipande viwili. Kipande cha kwanza na kipande cha pili. Hivi basi hii sehemu ni kipande na hiki kingine ni kipande. Mpendwa mwanafunzi, ningependa bado tuangalie hivi vipande huwa vina majina yake. Na hizo ni baadhi ya istilahi bado. Unapata kwamba katika baadhi ya mashairi hivi vipande vinaweza kuwa kimoja, vinaweza kuwa viwili, vinaweza kuwa vitatu ama vikawa vinne. Hivyo basi kipande cha kwanza ndicho ambacho kinaitwa ukwapi. Kinaitwa ukwapi. Ukwapi tumesema ni nini? Ni kipande cha kwanza cha mshororo. Kipande cha kwanza cha mshororo. Kwa mfano katika hiki kipande, katika huu mfano ambao tuko nao hapa juu, huu unaweza ukaitwa ukwapi. Kipande cha kwanza kinaitwa ukwapi. Kipande cha pili kitaitwa utao. Kipande cha pili kitaitwa utao. Ni kipande cha pili cha mshororo. Kipande cha pili cha mshororo kinaitwa utao. Hivyo basi katika mfano wetu hapa tunaweza kuwa na hii sehemu ikiitwa utao. Mwanafunzi, ningependa nikukumbushe kwamba nilisema kwamba mshororo unaweza ukawa na kipande cha kwanza, cha pili, cha tatu ama cha nne. Kumaanishaje? Kwamba kuna uwezekano pia wa kuwa na kipande cha tatu katika mshororo. Hicho kipande nacho kitaitwa mwandamizi. 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 Hicho basi ni kipande cha tatu cha mshororo. Kipande cha tatu cha mshororo. Kipande cha nne. Kipande cha nne. Kipande cha nne tunaweza kukiita ukingo. Kipande cha nne tunaweza kukiita ukingo. Hivyo basi ukingo ni kipande cha nne cha mshororo. Hapo nafikiri tumeweza kuelewa vipi kwamba nimesema mshororo ni mstari wa maneno, ubeti ni kifungu cha mishororo kadhaa, kipande nacho ni kisehemu katika mshororo. Na tukasema vipi mshororo unaweza ukawa na vipande viwili, kimoja, vitatu ama vinne. Na tukasema hivi vipande huwa vina majina yake. Kipande cha kwanza tukasema kwamba kinaitwa ukwapi, cha pili kinaitwa utao, cha tatu mwandamizi na cha nne kinaitwa ukingo. Basi nitatoa tu mchoro kidogo tu kwa ajili yako wewe mwanafunzi uweze kuelewa zaidi. Na nitatumia tu mfano ambao nilikuwa nimetumia pale, ambapo tulisema kipande cha kwanza, kuna kile cha pili, kuna kile cha tatu na kuna kile cha nne. Tulisema vipi? Cha kwanza kitaitwa vipi? Ukwapi. Cha pili utao. Cha tatu mwandamizi. Cha nne ukingo. Bado hatujamaliza istilahi. Nataka nigusie mengine. Tulisema mishororo katika ubeti. Basi iwapo aghalabu utapata baadhi ya mashairi yale mengi sana huwa ni ya mishororo minne katika kila ubeti. Hii mishororo huwa ina majina yake. Mshororo wa kwanza katika ubeti, hasa katika shairi la tarbia, shairi ambalo lina mishororo minne, mshororo wa kwanza huitwa mwanzo. Mwanzo. Kuna baadhi ya vitabu ama baadhi ya waandishi utapata wanauita fatiha bado Fatiha ni mshororo wa kwanza katika ubeti. Mshororo wa kwanza katika ubeti. Huo ndio mwanzo au kitaka fatiha bado. Aya, mshororo wa pili tunauita mloto. Huo ni mshororo wa pili. Mshororo wa pili katika ubeti. Mshororo wa tatu tunaweza kuita mleo au kitaka mlea. Huo ni mshororo wa tatu. Mshororo wa 4 hasa nimesema katika baadhi ya mashairi, na mashairi yenyewe sana sana huwa ni yale ya tarbia. Unapata pia unaweza ukaitwa kiishio, unaweza kuitwa mwisho. Ya, huo ni mshororo wa 4 wa mwisho. Mshororo wa 4 na wa mwisho. Mwanafunzi, nafikiri mpaka hapo tuko pamoja. Naomba kuongezea hizi istilahi kwa sababu ni nyingi tu sana. Hapo pia tumesema mambo kuhusiana na mishororo. Tumesema kuna mshororo ambao unaitwa mwanzo, hasa katika mashairi ambayo ni tarbia. Mshororo wa pili unaitwa mloto, wa 3 unaitwa mleo au mlea, wa 4 unaitwa kiishio au kitaka mwisho. Bado kuna istilahi nyingine ambazo tunafaa pia tuzishughulikie, hasa ambapo tutaangalia kibwagizo. 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 Kibwagizo pia utapata kinaitwa mkarara. Mkarara. Ya, kibwagizo au mkarara. Utapata kuna baadhi ya mashairi ambayo huwa na mishororo ambayo hurudiwa, na aghalabu utapata mishororo hii huwa ni ule wa mwisho. Ya, unarudiwa kwa ajili ya kusisitiza ujumbe katika shairi lenyewe. Ya, ili uweze ukapata ujumbe. Ni mshororo wa mwisho unaorudiwa. Huo ndio mkarara. Kuna neno jingine ambalo ni mizani. Mizani. Mizani ni idadi ya silabi katika mshororo. 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 Nataka nikupe mfano tu wa mshororo, kisha tujaribu kuhesabu baadhi ya mizani katika mshororo wenyewe. Mfano mshororo mmoja ni chukua kigoda jamaa. Chukua kigoda jamaa. Ukalie kilimani, samahani. Ukalie kilimani. Wacha tuangalie mishororo hiyo miwili tu. Nimesema vipi kwamba mizani ni idadi ya silabi katika mshororo. Silabi tunajua kwamba ni pigo moja katika utamkaji. Hivyo basi katika chukua kigoda jamaa, ukalie kilimani. Tuangalie baadhi ya mapigo. Kuna pigo la kwanza chu, pigo la pili ku, pigo la tatu a. Kwenye hilo neno jingine kisha kuna go, da, ja, ma, a. Tuhesabu sasa hizo silabi. Tuna 1, 2, 3, 4, 5, 6, 7, 8, 9. Hivyo basi idadi ya mizani hapo ni 9. Tuangalie katika mshororo unaofuata. Ukalie kilimani. Twende tena. U-ka-li-e ki-li-ma-ni. Hizo ni silabi. Tuzihesabu tena. 1, 2, 3, 4, 5, 6, 7, 8. Mizani ngapi? 8. Mizani 8. Hivyo basi nafikiri umepata kuelewa maana ya mizani. Mizani ni idadi ya silabi. Tuangalie neno jingine hapa ambalo ni vina. Vina. Vina ni nini? Vina ni silabi ya mwisho. Silabi ya mwisho katika kipande. Silabi ya mwisho katika kipande. Silabi ya mwisho katika kipande. Nafikiri wakati ambapo tulikuwa tunaangalia vipande, tulisema kuna kipande cha kwanza ukwapi, cha pili utao, cha tatu mwandamizi, cha 4 ukingo. Hivyo nataka tuweze kuangalia hapa. Nitaweza kuuchora mchoro fulani pale kwa ajili yako wewe kuelewa vina ni nini. Hivyo basi mwanafunzi, naomba uweze kufuata zaidi kwa mazingatio na makini zaidi. Nimeweza kueleza hapa kwamba vina ni silabi ya mwisho katika kipande. Kipande cha kwanza ambacho tuliita ukwapi kinaweza kuwa na kina, tuseme hapa mwishoni ni pa. Hicho ni kina. Kipande cha pili kiwe na kina kingine ambacho ni le. Ya? Tuseme umesema maneno yako unaishia kwa silabi pa. Katika kipande cha pili unasema maneno yako unamalizia kwa silabi le. Hicho ni kina. Hivyo hivyo katika mshororo wa pili pa, mshororo wa tatu le. Mshororo wa tatu kuna pa na kipande cha pili le. Namna hiyo. Hapa inaweza ikabadilika kidogo inakuwa le, hapa ma. Namna hiyo. Hivyo basi ukija kuangalia hii silabi ya mwisho katika ukwapi ni kina, ni hivi vyote tunapata ni vina. Na upande ule mwingine tunapata kuna vina vya upande wa pili, kipande cha pili ambacho ni utao. Aya, utapata kwamba hivi vina huweza kuainishwa kama vina vya ndani ama vina vya nje kulingana na mahali ambapo kina chenyewe kilipo. Aya, hivi ambavyo unapata ni vina vya ukwapi ndivyo ambavyo unapata kwamba vinaitwa vina vya ndani. Wengine hutumia neno kati. Vina vya kati. Hivyo vinakuwa ni vina vya ukwapi. Vina vya ukwapi ama vina vya ukwapi ndivyo ambavyo vinaitwa vina vya ndani au vina vya kati. Tunapata kuna vina vingine ambavyo ni vya utao. Navyo vinaitwa vina vya nje. Vinaitwa vina vya nje ama vina vya mwisho. Tuna vina vya nje au mwisho. Hivi ndivyo tunaita vina vya utao. Istilahi nyingine ambayo ningependa kuzungumzia ni neno malenga. Malenga tulisema kwamba mashairi ni tungo za kisanaa, ni utungo wa kisanaa. Hivyo basi kuna mtu ambaye amefanya ile kazi ya kutunga. Huyo ambaye anatunga hiyo kazi ya kisanaa ni msanii anayeitwa malenga. Hivyo basi huyo ni mtunzi wa mashairi. Mtunzi wa mashairi. Kuna mwingine ambaye tunaweza kumuita manju. Muite manju. Manju ni mtunzi pia, lakini huyu hufanya mengine zaidi ambayo ni kuimba mashairi yenyewe. Huyu ni anayetunga na kuimba mashairi. Ndiyo, kuimba. Kuna baadhi ya mashairi utapata pia yanaimbwa kwa ajili ya kutumbuiza, kupitisha ujumbe kutoka kwa msanii hadi kwa hadhira. Lakini utapata kuna baadhi ya vitabu ama tuseme mitihani ambayo hutumia neno jingine. Unasikia shaha. Neno shaha pia. Shaha ni mtu ambaye ni mweledi katika kutunga na kuimba. Kipawa chake huwa kiko juu zaidi kuliko hawa manju na malenga. Huyu ni kama manju na malenga, lakini kipawa chake kiko juu zaidi. Anayetunga na kuimba mashairi aliye mahiri zaidi kuliko manju na malenga. Nafikiri mpaka hapo mwanafunzi umeweza kuelewa baadhi ya istilahi ambazo zinatumika katika ushairi, ukaelewa maana ya ushairi. Hivyo basi nikihitimisha, nataka nikupe kazi mradi ambayo unafaa kushughulikia kabla ya kipindi kijacho, ambapo tutakuwa tunashughulikia mambo kuhusiana na kategoria mbalimbali za mashairi, kisha tuangalie baadhi ya bahari za mashairi. Basi kazi mradi yako itakuwa ndio hii. Kulingana na kile ambacho tumeshughulikia kwa leo, nataka unitajie kazi mradi swali lako la kwanza ni taja na ueleze istilahi 7 zinazotumika katika uwanja wa mashairi. Jambo la pili, ni andika shairi la ubeti moja kuhusu darasa lako. Kumbuka kwamba katika somo letu la leo nataka tu kutoa kama vile muhtasari. Tukashughulikia maana ya shairi, ambapo tulisema kwamba ni utungo wa kisanaa. Kumbuka kutaja kwamba ni utungo wa kisanaa. Unatumia lugha ambayo ni teule, lugha iliyoteuliwa. Kumbuka kutaja kwamba una mpangilio maalum wa maneno kwa ajili ya kuwasilisha ujumbe. Nafikiri mpaka hapo. Hivyo basi baada ya hapo tukaangalia mambo kuhusiana na baadhi ya istilahi, ambapo tuliangalia mambo ya mshororo ni nini, beti tukaangalia aina mbalimbali za mishororo katika mashairi, tukaangalia vipande katika mishororo, vina, mizani, na malenga, manju na shaha, ambapo basi nafikiri ni rahisi sana kwako wewe kufanya ile kazi ambayo nimekupa wewe, na ni rahisi sana hata kutunga shairi lako ukizingatia yale mambo ambayo nimeweza kushughulikia kwa leo. Upange kazi yako vizuri katika beti, upange mishororo 2-3 kuhusiana na darasa lako, uipange katika ubeti. Hakikisha kwamba kazi yako iko na mizani ambayo ni sawa katika kila mshororo, na basi utakuwa ushamaliza kutunga shairi lako mwanafunzi. Asante sana, siku njema. Hadi kipindi kingine tutakapokuwa tunashughulikia kategoria za mashairi na bahari za mashairi. Asante, shukran.
Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Welcome to Manifested Publishers.
Hello learners, welcome to this biology lesson. My name is Stephen Kariungi. Today we are discussing the topic cell physiology, and this is a continuation from what we did during the last lesson. So last lesson we introduced the topic, and we also discussed the structure and properties of cell membrane. Today we shall continue looking at the physiological processes that are used during the study of cell physiology. So these physiological processes are the processes that allow, movement of substances across the cell membrane. So they are the processes that allow the movement of substances across the cell membrane. Now, which are these processes? They include: 1, we have diffusion, we have osmosis, and we have active transport. So those are the 3 physiological processes that are responsible for the movement of substances across the cell membrane. So we will start with the first process, and this is diffusion. Now, we want to ask ourselves, what does the word diffusion mean? Now, diffusion is the movement of particles from a region of high concentration to a region of low concentration. So we are talking about the movement of particles from a region of high concentration to a region of low concentration until an equilibrium is established, until the 2 regions are balanced, until they have the same concentration. So in this case, we can say that this is the movement of particles from a region of high concentration to a region of low concentration until an equilibrium. An equilibrium is a balance. Until an equilibrium is achieved. So for example, if I have a gas here that has a very strong smell, and then I release it, it will spread throughout the room. So the spreading out of those gas particles is by diffusion. So we will say that those particles have diffused until such a time that the entire room gets those particles. And you can be able now to get the smell of that particular gas. Now, I want us to look at what are some of the experiments that one can carry out to demonstrate diffusion. One of the experiments that we can use to demonstrate diffusion, we can have a beaker and then inside that beaker, using a straw, we introduce a crystal. We introduce a crystal and then we put some water into the beaker. So we have water, we have a beaker, and then we have a crystal. Let's take, for example, a crystal of potassium manganate 7. So this is a straw. This is the beaker. We put some water, and then we have a crystal of potassium manganate 7. So that is what we have at the beginning. So once we have introduced the crystal, we remove the straw so that the crystal is left at the bottom of the beaker that contains water. And then we leave it for a few hours, let's say like 4 hours. Now after 4 hours, this is what we shall observe. So we shall observe that the entire solution becomes purple. So we have a purple solution. So this is B at the end. At the end of 4 hours, we have the beaker and the rest. So we are saying what has happened is the crystal of potassium manganate 7 has diffused within the water, slowly by slowly, until the entire water is covered by potassium manganate 7. So the entire solution will turn purple. So you can say entire solution becomes purple. Okay, this is a purple solution in entire. So the next thing that we are going to look at, what are the observations? How can we state those observations? So we are saying that after 4 hours, the entire solution becomes purple. So at the beginning, the water was colorless. Then we introduced the crystal, or just one crystal of potassium manganate 7. Then we remove the straw, we allow the crystal now to diffuse within the water until at the end we find that the entire solution is now purple. Now, what is the reason for that? So now we look at the conclusion. So how to explain that? We shall say that the crystal of potassium manganate 7 diffused through water until the entire solution turns purple. So what we can say is that diffusion has actually taken place. So in this case, we are saying that the region of high concentration is the potassium manganate 7 crystal. Then it spreads out to the entire solution. So that is diffusion. So there are so many experiments that you can use. And like I said earlier, someone can come with a gas that has a very strong smell and open it in the room. And everyone who is in that room gets the smell of that particular gas. That is because there is actually diffusion that has taken place. So we started by mentioning the 3 physiological processes: diffusion, osmosis, and active transport. Then we went on to define diffusion as the movement of particles from a region of high concentration to a region of low concentration until an equilibrium is achieved. An equilibrium, I said, is a balance, until a balance is achieved, like we can see here. Then we have seen an experiment that we can carry out to demonstrate diffusion. We introduce a crystal of potassium manganate 7 using a straw, then we leave it there. After 4 hours, we come and observe, and you will find that the entire solution will have turned purple to show that there is actually diffusion. So the observations are as follows, and then also the conclusion. So we'll stop there and then have the assignment for the day. So the assignment is as indicated there. The first question, define the term diffusion. The second question, describe an experiment to investigate diffusion. And number 3, state the observations in the experiment 2 above. In experiment number 2, what are the observations that you'll make in that particular experiment? So we'll stop there for today, and goodbye.
Welcome back to this lesson on solving problems in pressure in solid. In the last lesson, we had done 3 questions and I had given you an assignment of 3 questions. Let me hope you have attempted, and I'm going to take through the 3 questions so that you can rectify where you had made a mistake. These are the questions. Question 1. A metallic block of mass 40 kilogram exerts a pressure of 20 Newton per meter squared on a flat surface. Determine the area of contact between the block and the surface. In our previous lesson, we had said that pressure is equals to force over area. Now I'm going to solve this. Solution. we have been given, question 1, we have been given the mass as 40 kilograms. Mass given by 40 kilograms. Then we have pressure as 20 Newton per meter squared. And we know that pressure is given by force over area. We are being asked to determine the area, meaning that we are going to use this formula to make area the subject of the formula by multiplying both sides by area and dividing both sides by pressure. This simply means that if I want to get area, I just take force, then I divide it by pressure. Now, from the variables that we have been given, we don't have force, but mass is going to assist us to get this force. We have pressure, meaning that we must work out force. So, working force is given by mass times G. G is force of gravity, and you have been given. And that if I want to get force, I just take mass, which is 40, then times G, 10. This gives me 400 newtons. So if I have force, I have pressure, I can substitute in my formula, then I get area. So my area is given by force, that is 400 Newton over pressure, which is 20 Newton per meter squared. So if I divide this, it gives me 20 meters squared. This is the area that a metallic block is supposed to have in contact with the surface. That is question 1. So let's try this question 2. Question 2. Question 2, it says, a man whose mass is 90 kilograms stands on a floor. If the area of contact between his feet and the floor is 0.0368 meters squared, determine how much pressure he is able to exert on the floor. So that is question 2. We have been given that is mass. Mass is given by 90 kilogram. Part A, we have the same mass, but we have also the area. So area is given by 0.0368 meters squared. We are being asked to determine the pressure. And we know that pressure is equals to force over area. So pressure is given by force over area. We have the area, we don't have force, but we have mass. We are going to use this mass to get force. We know that force is given by mass times G, that is force of gravity. So mass, we have 90 times G, which is 10. This one gives me 900 newtons. 900 newtons. So we have force, we have area. We substitute it into our formula, whereby now pressure, it will give us force 900, then divide by area which is 0.0368 meters squared. So when you use the calculator, we have 900 divided by 0.0368. It gives me, that is 24,456.52 Newton per meter squared. That is the pressure that is supposed to be exerted. Then part B. For part B, what pressure will he exert on the floor if now he stands on 1 foot? So remember, the area for feet is 0.0368. So for 1 foot, we are going to calculate the area of 1 foot by dividing the given area by 2. So you have area given. We have area of 1 foot is equal to 0.0368 divided by 2. Divide by 2. So you have 0.0368 divided by 2 is equal to 0.0184. 0.0184 meters squared. Still, we have the same force. Our force is still equals to 900 newtons. So if I want to calculate the pressure, we have seen in the part A, our pressure is given by force over area, which gives us force 900, then over area 0.0184. So you can use, that is 900 divided by answer. So it gives us 48,913.04 Newton per meter squared. This is the pressure that can be exerted by 1 foot on the floor. Then the last part, that is question 3, we are also going to simplify it. Question 3, a roof has a surface area of 20,000 square centimeters. If pressure exerted on the roof is 100,000 Newton per meter squared, determine the force on it. So we have been given, that is question 3, we have been given the area as 20,000 centimeters squared. Then we have pressure as 100,000 Newton per meter square. We are being asked to determine the force. And from the general equation, pressure is given by force over area. Meaning that if I want to get force, I multiply both sides by area. So this simply means that my force is given by pressure times area. Force times area. Now, we have area, we have pressure. But this area, it has been expressed in square centimeters. We must convert it back to the SI unit. That is meters squared. So we have here our working. We know that 10,000 centimeters squared is given by 1 meter squared. So what about 20,000 centimeters squared? So we cross multiply. We have 20,000 centimeters squared times 1 meters squared, then over 10,000 centimeters squared. So this gives me 2 meters squared. So we have our area. This is our area. So we have pressure. So I have my area, I have my pressure. So I substitute in. Pressure is 100,000 Newton per meter squared times area, which is 2 meters squared. So if I multiply this, it will give me 200,000 newtons. This is the lesson of today, and this is how we are supposed to work out these questions. So meaning that we have done 6 questions in this area of solving problem in pressure in solids. So I'm also going to give you 3 more questions so that you can attempt when you are at home. We have assignment. So these are the 3 questions that I would like you to try. The first one is a pressure of 2,000 pascals acts on an area of 0.05 meters square. What force is produced? And question 2, we have a pickup carrying stones weighs 20,000 newtons. The weight is evenly spread across the 4 tires. The area of contact of each tire with the ground is 0.025 meters squared. Calculate the pressure exerted by each tire on the ground. Question 3. If atmospheric pressure is 101,000 Newton per meter squared, what force is exerted on a wall of area 12 meters squared? This is squared, 12 meters squared. So these are the questions that I would like you to try when you are at home. That marks the end of our lesson today. God bless you. Bye-bye.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. We continue with our biology lesson and the topic of discussion is cell physiology. So we are continuing from where we reached the last time, and today we are looking at the factors that affect the rate of diffusion. So in other words, we are asking ourselves, what are some of the factors that are likely to make diffusion to occur faster or slower than usual? So we'll have those factors. So one of the factors that affect the rate of diffusion is a factor called diffusion gradient. Diffusion gradient or concentration gradient. Now, what does that mean? Diffusion gradient is the difference in concentration between two surfaces. You may have one surface that is of high concentration and another surface that is of low concentration. So we can say that there is a concentration gradient. So in other words, we can say that this is the concentration difference between two regions. The concentration difference between two regions. So in this case, what we say is that the higher the concentration gradient, the faster the rate of diffusion. Or we can say the steeper the concentration gradient, the faster the rate of diffusion. So if two surfaces have a very wide difference between them, then it means that the rate of diffusion will be faster. But if the difference is almost the same, then the rate will be slower. Now, the second factor that we shall learn about is the thickness of membranes. Diffusion takes place across some membranes in the cells, like for example the cell membrane that we have or that we learned earlier. Now, so we can say that the thicker the membrane, the slower the rate of diffusion. So we are saying that the thicker the membrane, the slower the rate of diffusion. Because the particles cover a longer distance. And vice versa. So the vice versa says that if the membrane is thin, then the rate of diffusion is faster because the particles will go through a shorter distance. The third factor is the size of the particles. The particles that are diffusing, what size are they? If the particles are very heavy and very big, they tend to move slowly. And if the particles are small and light, then they tend to diffuse faster. So we can say large sized particles take longer to diffuse than small size particles due to density or due to the weight of the particles. Another factor is the temperature. When the particles are heated, they tend to diffuse faster. What does that mean? That the temperature gives kinetic energy to the particles, making them to be able to move faster than before. So we are saying that temperature increases or you can say increase in temperature. Increases the kinetic energy. Of the particles making them to move faster. So that is temperature. Point number 5, there is the surface area. And we can say that the wider the surface area, the faster the rate of diffusion. The faster the rate of diffusion. So if the surface area is wide, then the particles are able to diffuse faster. So today we have learnt about the factors that affect the rate of diffusion. We have seen the diffusion gradient or the concentration gradient, which we have said is the concentration difference between two regions. And the steeper the difference or the wider the difference, the faster the rate of diffusion. Then we have also seen the thickness of membranes. Some membranes are very thick, and therefore the diffusion of the particles is slow because the particles are covering a long distance. Number 3, the size of the particles. There are those particles that are of large size, others are of small size. The ones that are of large size, they will tend to take longer to diffuse because of their high density and their large size. Temperature, we have said that increase in temperature, for example, when you heat something, you increase the kinetic energy of the particles. So you make those particles to move faster, to diffuse faster than if the temperature is low. Then finally, we have seen the surface area, and we have said that the wider the surface area, the faster will be the rate of diffusion. So we are going to stop there for today, and the next thing that we are going to have is the assignment. So the first question, explain the term diffusion gradient. Number 2, also explain how the following factors affect the rate of diffusion. A, we have temperature, and B, we have the surface area. So the assignment for today, explain the term diffusion gradient like we have explained it. Number 2, explain how the following factors affect the rate of diffusion. And the first factor is temperature, and the second factor is surface area. So we are going to stop there for today. Goodbye.
Welcome to our lesson of today. We are still solving problems in waves 1 and I had given you an assignment yesterday that you are supposed to have done. Let me hope you have done, and I'm going to go through them. Now, I had left here 3 questions. The first question says a rope is displaced at a frequency of 3 hertz. If the distance between 2 successive crests of the wave train is 0.8, calculate the speed of the rope. Now, when you are discussing these characteristics of a wave, we defined the term wavelength. We said wavelength is the distance between 2 successive crests or troughs when a wave is under train. So from this question, it is clearly indicating that the wavelength is 0.8 because it's the distance between 2 successive crests. So solution for question 1. We have been given the frequency of a wave, frequency f3 hertz. Then we have also wavelength, lambda, which is 0.8 meters. So they are asking us to calculate the speed of along the rope. So in the lesson we said, the last lesson, that this speed is given by frequency then multiply by lambda or wavelength. We have frequency, then we have our wavelength. So we just substitute in our formula. So you have 3 times 0.8. This gives us 2.4 meters per second. So this is the speed of that rope or of a wave along the rope. This is the solution for question 1. Now for question 2, the question says, the figure below illustrates parts of the displacement time graph of a wave traveling across water at a particular place with a velocity of 2 meters per second. Calculate the wave's amplitude, frequency, and wavelength. This is the diagram. So question 2, that is A. They are asking us to determine the amplitude of a wave. And from the definition, amplitude is the maximum displacement of a wave from the mean position. From my diagram, the x-axis, the time axis, the x-axis with the time axis, this is my mean position. So the maximum displacement of this wave, it becomes 0.4. Now I can say from the graph, the maximum displacement, that is A, of a wave is 0.4 centimeters. Remember, this displacement is in centimeters. So this is 0.4 centimeters. Then part B, that is for frequency. We want to determine the frequency of this wave. Now, from the relationship between frequency and period, we said that frequency is given by 1 over t. But we don't have this t. We can calculate using this diagram. Now, from the graph, period t This is the time taken by a wave to complete one oscillation. So an oscillation is made up of two halves. So meaning that time taken to complete one oscillation from the diagram, this is the first half, this is the second half. So if I add the two halves, they will give me one oscillation. Now, meaning that my period from this diagram, time taken to complete one oscillation, then is equivalent to 0.2. So this means that my period t is equal to 0.2 seconds. Now, when I want to find my frequency, so I substitute my formula. So my f is equivalent to 1 over 2, which is equals to 1 over 0.2. 1. So we take, that is 1 divided by 0.2. It is giving me 5 hertz. That is part B. Then for part C, the wavelength. Now, the formula relating wavelength, frequency, and speed, we know it. That is V is given by frequency, then times wavelength. This is wavelength, this is frequency, this is speed. Meaning that if I want to get wavelengths, then I can divide both sides by F. I have V over frequency. From my calculations here, I have frequency. Then speed, that is V, velocity, we have been given it is 2 meters per second. It is here. So we have speed, we have then frequency. So we just substitute in our equation. So this one gives us 2 over 5. 2 over 5 is equals to 0.4 meters. So this is our lambda. Lambda is wavelength. So we have calculated the wavelength, we have our frequency, then this is our maximum displacement, that is amplitude. So we have our amplitude, then we have our frequency, it is here, then we have our wavelength, which is here. So this is solution for question 2. Let us move to the last question, that is question 3. Question 3. Question 3. Distinguish between longitudinal and transverse wave. So we can as well have, we can tabulate it. We can have something like a table, so that the first column we have transverse wave, then the second column we have longitudinal. So for transverse wave, we have two differences between longitudinal and transverse wave. For a transverse wave, the vibration of particle and is always perpendicular to the wave motion. So for transverse wave, if it is the first difference, is that the vibration of particle is perpendicular to the wave motion. While for longitudinal, sorry, here it is longitudinal, the vibration of particles is parallel to the wave motion. That is the first difference. This is the first difference. The second difference, we always say that transverse wave, it travels in a series of crests and troughs. While for longitudinal, this one, it travels in a series of compression and rarefactions. So this one, it travels, transverse wave travels in a series of crests and trough, while longitudinal waves travels in a series of compressions and rarefactions. So these are the two differences between transverse wave and longitudinal wave. When you move to longitudinal, that is waves 2, you realize that you'll have some that have been left out. But according to as per our knowledge, we can give just the two differences. So this marks the end of the discussions of the three questions. But I would like to give you two more questions that you can attempt when you are free. So let me give you two more questions. So these are the questions that I would like you to attempt. The first question, waves on a spring are produced at a rate of 20 wavelengths every 5 seconds. Find the frequency of the wave. B, if the wavelength of a wave is 0.01 meters, find the speed of the wave. C, find the period of the wave. Then question 2, the figure below shows a wave. Determine the frequency of the wave given that the wave speed is 340 meters per second. So kindly try to attempt this question. This marks the end of our lesson. May God bless you. Bye-bye.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi and we continue with our topic of discussion and we are discussing genetics. So in our previous lesson, we learned about inheritance of A, B, O blood groups and today we are going to discuss how to show genetic diagrams of blood groups, or how to predict the blood group of the offspring given the blood group of the parents. So genetic diagrams showing inheritance of blood groups. We talked about blood group A and B being codominant or being equally dominant, such that a person who has gene A and a person who has gene B, if they were to marry each other, they may end up getting children with the blood group AB. And that's why we say that blood group AB is codominant. But we also said that blood group O in heterozygous state does not express itself, especially in the presence of gene A or B. The blood group O is not recognized because it's a recessive gene. So the only time blood group O can express itself is when it is in homozygous state, but not in heterozygous state. Now, we'll take a scenario, and we say that a couple has blood group. Okay, you can say that a couple is heterozygous for blood group A, that is the man, and blood group B, that is the woman. Then you are told determine the probability, of bearing a child with blood group O. So a couple is heterozygous, that is the man is heterozygous for blood group A, and the woman is heterozygous as well for blood group B. Then we are told determine the probability of bearing a child with the blood group O. Or in other words, is there a probability of getting a child with blood group O from a man who is blood group A and the woman who is blood group B? So we can show that in form of a genetic diagram, whereby we start with the parental phenotype. So this is the man and that is the woman. So the man is blood group A. Remember, blood group is the phenotype, and the woman is blood group B. Then we are told that both are heterozygous, so parental genotype. So A will be AO. That's what it means by being heterozygous, meaning that he has the allele for A and O. And then the woman, we must show the cross, very, very important, is also heterozygous, that is BO as well. She has two different alleles. The man also has two different alleles. Then the gametes, we have A and O, and then for B we have B and O. We must circle the gametes and make sure that those gametes are not punctured. And then we do the fusion using a Punnett square. Remember, we can also use a genetic cross diagram, but if we are told to use a Punnett square, we should use a Punnett square. So this is the woman and this is the man. The man is AO, the woman is BO, So after crossing, we'll get AB, we'll get AO, we'll get BO, and we'll get OO. So this is the F1 genotype. So the phenotype are the blood groups. We have blood group A is there, B is there, AB is there, and O. That means all the blood groups are there. There is A is here, B is here, AB, and O. So remember, when B and O occur together, B dominates. Where A and O occur together, A dominates. O can only express itself if we have homozygous recessive state, OO. So we can conclude there and say that from the above genetic diagram, it is possible for the couple to bear a child with blood group O. There is 1/4 or 25% chance for blood group O. 1 out of 4. So we have 1 out of a total of 1, 2, 3, 4. So at that point, we'll have an assignment. We'll have an assignment still in a genetic cross diagram showing how the blood groups are inherited. So the assignment, the first question, a man is homozygous. That means the two alleles are identical, homozygous for blood group A, while the woman is homozygous, the two alleles are identical for blood group B. Determine if there is a probability of a child with blood group O. Use a Punnett square to explain. Number 2, explain why blood group O is a universal donor. Explain why blood group O is referred to as a universal donor. So we'll stop there until next time. Goodbye.
Welcome to Manifested Publishers.
How are you, Anna? Welcome to our today's lesson. I'm your teacher, Conan Gakure. We are continuing with our learning on the establishment of colonial administration in Kenya, or colonial rule in Kenya. And in the previous lessons, we have been studying the response of the Kenyan people to the coming of the British occupation of Kenya. And we discovered that the people, they reacted in 3 ways. They either resisted, or they collaborated, or they had mixed reactions. So we had started with the first response, which is resistance. We have already covered one community that resisted against, resisted the British occupation of the Kenyan territory, that is the Nandi. We were able to learn the causes of the Nandi resistance, how they resisted the British rule, and the reasons why they were able to put up a very long resistance. They resisted the British for a period of 10 years. That was a very long time resisting. Every now and then the British could send expeditions against them, but these expeditions could not be able to outmaneuver the Nandi. And we also studied the reasons why they were eventually defeated, the factors that contributed to them being defeated, and also finally we were able to learn about the reasons or the results or consequences of their resistance against the British. So that is the first community that resisted the colonial administration in Kenya. So today we are going to move further and look at the second resistance, that is the Agiriama resistance. The Agiriama resistance, that is the second group that we are going to study in our lesson today. In our lesson today, we are going to look at the cause of their resistance, how they resisted the British rule, and also learn about the reasons why they resisted the British rule. So the Agiriama resistance, this is the Agiriama community is part or is a community among the coastal Bantus. They are part of the Mijikenda. So they are found in the coastal part of the Kenyan territory. So if you could get your atlases and be able to locate on your map the map on the people of Kenya, you are going to locate the Agiriama people in the coastal part, in the southern part of the Kenyan nation. So this is part of the coastal Bantus, and they had settled in this place earlier, even before the coming of the British. So in their lives, they were farmers. They were traditionally farmers. They engaged in farming. So they had fertile land that they engaged in. So they could produce products that they sold to the coastal communities, the communities that were living along the coast. And with the coming of the Arabs, they could also sell them to the Arabs. Apart from that, they also engaged in trading. They engaged in long distance trade that had been established during the 19th century with the coming of the Arabs. So they were an essential part. They acted as middlemen. They acted as middlemen. So they were a contact between the interior communities, that is the Akamba, who are also selling goods from the most interior parts of Kenya, and also the Arabs at the coast. So they were middlemen at that time. They could exchange their products for other products. So they could also sell them in exchange of currencies that had now developed. So they were trade was a very important part of their livelihood. But now, with the coming of the British established plantations. They came and established plantations at the coast. The British came, talking of the British, came and established plantation. They were planting cotton and rubber at the coast. So they established large plantations of cotton and rubber. And the only way they could be able to plant or be able to develop these plants was through the use of Agiriama, providing them with labor. So the resistance of the Agiriama started with them refusing to work in the British plantations. That is how the resistance started. The British, after they had come and were establishing the cotton and rubber farms, they conscripted or they forced the Agriama people to work in the plantations. So the Agriama decided to refuse. They resisted working. They resisted to provide their labor in the British plantation. So that is how the resistance of the Agriama started. So with that, the British opted to force them by imposing taxes. So they imposed a tax of a tax on the people to make sure, and the tax was supposed to be paid in cash. And the way they could get that cash is from working in the plantation. So when the British saw that when they are asking the Agriama to work in their plantation, they have resisted, they resorted to imposing taxation on the Agriama people so that they could be forced to work in the plantation, so that they could be able to raise the cash required for the taxation. So with the taxation, the Agriama also refused even to continue working. In turn, they opted to continue with their trading activities so that they can raise the cash to pay for the taxation. This angered the British because no matter what they are trying to do against the Agriama, they are continuing to resist and refuse to work in the plantations. So the Agriama defied every manner of order that was given by the British. So that angered the British so much until one of the colonial leaders, who was known as Hobley, who was the provincial commissioner at the time, came to see or visited the area of the Agriama because of how the Agriama had resisted and refused totally to follow all the orders that they were given by their leaders. So when he came, the Agriama tried to raise their grievances to the British provincial commissioner. But the PC at that time, as he was abbreviated, the PC, the provincial commissioner, refused to listen to their grievances. So the people resorted to totally refuse to cooperate with the British. They were led by two significant leaders. Remember, the people who were bringing the grievances of the people to the commissioner were these two leaders. One was a lady who was known as Mekatilili wa Menza. That was one of the leaders, and also there was one also known as Wanje wa Madorika. Wanje wa Madorika. So this one was a woman that was very influential in the community. So she led the community together with Wanje wa Madorika to present the grievances of the Agriama people to the provincial commissioner. But they decided, the PC decided to refuse their grievances or to listen to their grievances, and told them they had to provide the labor in the plantations. So what did they do? Mekatilili wa Menza, together with Wanje, together with the other leaders, rallied all the Giriama people away from those plantations. Some of them even moved further into inland, away from the plantations, trying to run away from the British. While others, they were rallied them to the Kaya. They rallied them to the Kaya. Remember, the Agriama people were organized among Kayas. Those are clans or Kayas that are related families. So the Mekatilili wa Menza, together with the other leaders, rallied all the people to the Kaya, which was known as Kaya Fungo. Was known as Kaya Fungo. This was a shrine that was believed by the Agriama people. So these people moved, or the leaders marshaled all the people to this Kaya, where they could come and sit down so that they could chart the way forward. So when they came to the shrine, the people raised the different clans raised their grievances to these leaders, and they discovered that they have the same problems. They are being evicted from their lands to pave way for the plantations, and also they are being forced to work in those plantations. Another grievance that they were having, the tax had been imposed on them. So what that did at the Kaya Fungo, they decided to get oath. They decided to take oaths. An oath. They decided to take oath. Oath that bound them together. So they decided to take oaths that bound them together. They took allegiance. An oath is an allegiance. So if you take an oath, you have decided with the whole of your being that you are going to do a specific thing. So there are two kinds of oaths that were taken. One was referred to as mukushe. Kushe. So this was made by the men. This was for the men. And the other one was known as fusi. This was for the women. So when the people went to the Kaya Fungo, that is their shrine, that was very essential, and it had very strong religious impacts on them. So they made an oath of binding them together. So the men took the kushe oath, while the women took the fusi oath. These bound them together, and they vowed not to bow down or not to be intimidated by the British. So they decided to come together and revolt, totally revolt against the British. So they refused even to be paying the taxes. Remember, during this time, they were engaging in trade so that they could pay the taxation. So after the oath, they now totally refused. We are not going to pay even the taxes that you are telling us to pay, and they totally revolted against the British. So after the oath and the total resistance by the people, the British decided to capture these two leaders. So the leaders were captured. The leaders were captured. That is Mekatilili and Wanje. They were captured by the British, and they were leaders were captured and deported to Kisii. So you can imagine, from the coast, they were taken all the way to Kisii. Kisii is in western part of Kenya. So this was in an effort to scuttle the resistance. So the British tried by taking away the leaders, that is Mekatilili, who was a very strong lady that was bringing the people together, and Wanje. So they tried to take them away. By deporting them, they thought that they could now make sure that the resistance did not take place. But to their amazement is that the leaders who had been left, or the people, continued to resist and fight against the British. Even after they had been deported, the British commanded the community to move from their traditional Kaya, that is Kaya Fungo, and move to another Kaya. But the people refused. They refused to move, and now resorted to armed resistance against them. So, but the British now resorted to them using the scorched earth policy. in an effort to weaken or to bring the people to their knees, the scorched earth policy, so they could invade the communities. They could burn down the huts, the homesteads. Remember, as you learned in your Form 1 work, the Agriama were living in homesteads. They could have one family having all their houses together. So the British could come and destroy those houses. They even burnt down the fungo, the Kaya Fungo, which was a very essential shrine in the lives of the Agriama. So these further fueled, instead of demoralizing the people, it further fueled them to resist against the British. But now, with that, the British had superior weapons. So though they were fighting, though the Agriama people were trying to resist and fight against the British, they were eventually subdued because of the reinforcements that the British got, because of the strength of the weapons that the British got together with the scorched earth policy. Because when the homesteads were being burnt, the people did not have a place where they could live. So they were eventually defeated, and their resistance was brought to an end. But even as it was brought to an end, there was an agreement that was made. The taxation that has been put on them was lifted or was relaxed even after they had fought against the British. So in a nutshell, that is how the Agiriama resisted the British colonial rule. That is how the Agiriama resisted the British colonial rule. So that is how the Agiriama fought or resisted the colonial rule. I've mentioned they started as a resistance, just refusing to provide their labor. And then further on, it went to armed resistance, led by Mekatilili Wamenza, together with this was a very essential woman in the resistance, together with Wanje wa Madorika, right? So even during traditional societies, something that I just need to mention here is that women were also essential in fighting for the independence or fighting for the independence of the African communities, and especially Kenya. We see one person who is a woman fighting against the British. So women also have had their positions to lead. They have had an influence in the society. So that is women also have their position even in our modern society. So they need to be accorded the same respect just as the men, because you can imagine this is a woman that has stood and leading the whole community to fight against the British involvement in their activities. So as we end our lesson today, we have been looking at the cause of the Agriama resistance, how their resistance took place and how it continued. So we said eventually here they were defeated because of the strong weapons that the British had. So as we end our lesson today, here is a revision question. Revision questions, and the questions are: number 1, identify the leaders that led the Agriama resistance. That is number 1. And then number 2, describe the Agriama resistance. The first question, identify the leaders that led the Agriama resistance, that is one. And then number 2, describe the Agriama resistance. Describe the Agriama resistance. And that marks the end of our history and government lesson for today. Until our next lesson, bye-bye.
Welcome to Manifested Publishers.
Hujambo mwanafunzi wa kidato cha 4. Karibu katika somo letu la leo la Kiswahili. Kidato cha 4 ambapo tutakuwa tunashughulikia ushairi. Na hasa katika kitengo cha bahari za mashairi. Kidogo nikukumbushe kwamba katika kipindi hicho kingine kilichopita nilikuwa nimeshagusia kiasi kuhusiana na bahari za mashairi. Nikaeleza kwamba bahari ni ni mikondo mbalimbali ya mashairi, hasa kulingana na sura ya nje ya shairi lenyewe ama ya mashairi yenyewe. Hivyo basi tulikuwa tumeshasema ya kwamba kuna baadhi ya vigezo ambavyo vinatumika katika kuainisha hizi bahari, haya mashairi katika bahari mbalimbali. Moja kati ya kigezo kilikuwa ni kile cha idadi ya mishororo. Tukaangalia tukaona kwamba kuna shairi la mshororo mmoja tukaliita tathmina, la mishororo miwili tathnia, la mishororo mitatu tukaliita tathlitha, la mishororo minne tarbia, mishororo mitano likaitwa takhmisa, la mishororo 6 likaitwa tasdisa, la mishororo 7 likaitwa tasbia. La mishororo 8 likaitwa naudi au unani. La mishororo 9 likaitwa telemania au utisa. La mishororo 10 tukaliita ukumi. Na lile la mishororo 14 katika kila ubeti tukaliita soneti. Hayo ndiyo baadhi ya mambo ambayo tulishughulikia katika kipindi kilichopita. Ni muhimu kuyagusia. Basi katika hiki kipindi tutashughulikia kigezo cha pili. Na nilisema vipi? Kigezo ni criterion. Criterion. Katika wingi criteria. Basi ni criteria gani? Tunatumia kigezo gani kuainisha haya mashairi katika bahari mbalimbali? Kigezo cha pili ni kigezo cha vipande. Bahari ya mashairi kutegemea vipande. Hii ni nambari ya pili. Nambari ya pili ni bahari. Nambari ya kwanza tulishughulikia bahari za mashairi, samahani. Bahari za mashairi kwa kutegemea vipande. Nambari ya kwanza ni bahari ya mashairi kwa kutegemea idadi ya mishororo. Nafikiri unasafiri nami moja kwa moja, na nataka kuamini kwamba una daftari lako hapo na kalamu zako 2-3. Na kama basi hukuchukua, naomba uchukue uweze kuandika 2-3 kuhusu yale ambayo yanaendelea hapa kwenye ubao. Nafikiri una hilo daftari. Haya basi, bahari za mashairi kwa kutegemea vipande. Mashairi yamegawika kiasi kwamba tuna bahari ya kwanza ambayo ni utenzi. Nina imani kwamba mwanafunzi, msomaji wa lugha ya Kiswahili, pia mwalimu, unakumbuka nilipokuwa nikieleza istilahi mbalimbali za zinazotumika katika huu uwanja wa mashairi. Vipande ni visehemu katika mshororo. Visehemu katika mshororo. Kwa mfano, utenzi ni shairi ambalo mishororo yake ina kipande kimoja. Na hicho kipande kinaitwa ukwapi. Kinaitwa ukwapi. Andika: utenzi, shairi ambalo mishororo yake ina kipande kimoja ambacho ni ukwapi peke yake. Yaani sio kawaida ya vile ambavyo tunakuwa na vipande viwili. Ni mfano ni kama huu. Mfano, katika ubeti wa kwanza tunakuwa na mshororo wa kwanza, mshororo wa pili, mshororo wa tatu, mshororo wa nne. Huo ni ubeti wa kwanza wenye kipande kimoja peke yake. Tuangalie katika ubeti wa pili. Hivyo hivyo. Ubeti huu una mshororo wa kwanza ambao una kipande kimoja, mshororo wa pili wenye kipande kimoja, mshororo wa tatu wenye kipande kimoja, na mshororo wa nne wenye kipande kimoja. Hivyo hivyo mpaka ubeti wa mwisho. Hilo shairi liko katika bahari ya utenzi. Mashairi mengi ya kale kama vile utenzi wa Mwanakupona ni mfano mojawapo. Hasa sana utapata haya mashairi huwa ni marefu. Takriban beti kama 200 hivi. Na hasa sana huwa yanagusia mambo ya kihistoria, siasa, utawala, mashujaa, ushujaa na mambo mengine ya kijamii kama vile ndoa na kadhalika. Yaani haya mashairi utayapata yanaitwa utenzi. Yanakuwa na kipande kimoja katika mshororo. Na hiki kipande ndicho ambacho tulisema kwamba kinaitwa ukwapi. Ukwapi ni kipande cha kwanza katika mshororo. Tuangalie bahari ya pili. Bahari ya pili. Nafikiri umeshaandika huo mfano. Bahari ya pili ni Mathnawi. Mathnawi ni shairi ambalo mishororo yake ina vipande viwili. Ni shairi ambalo mishororo yake ina vipande viwili. Yaani ukwapi na utao. Yaani kipande cha kwanza na kipande cha pili. Aghlabu haya ndiyo mashairi ambayo tumeyazoea, ambayo unapata kila mshororo unakuwa na vipande viwili. Mfano ni kama huu. Mfano, Ubeti wa kwanza unakuwa na ukwapi na utao. Wa pili, ukwapi na utao. Wa tatu vivyo hivyo. Kipande cha kwanza tumesema kwamba kinaitwa ukwapi. Cha pili kinaitwa utao. Cha pili kiitwe utao. Hivyo hivyo katika ubeti wa pili unapata ukwapi, utao. Namna hiyo. Kipande bahari ya tatu. Bahari ya tatu, kwa kuzingatia kigezo cha vipande, ni hiki kingine ambacho kinaitwa ukawafi. Ukawafi. Ukawafi ni shairi ambalo mishororo yake ina vipande vitatu. Ni shairi ambalo vitatu. Ukawafi ni bahari ya shairi ambapo unapata mishororo ya shairi lenyewe ina vipande vitatu. Yaani cha kwanza ambacho tulisema kinaitwa ukwapi, utao na mwandamizi. Ukwapi, utao, mwandamizi. Mfano ndio huu. Mfano, ubeti wa kwanza una ukwapi, utao, mwandamizi. Mshororo wa kwanza. Mshororo wa pili nao hivyo hivyo. Namna hiyo. Huo ni ubeti wa kwanza. Ubeti wa pili, naweza nikatumia sehemu hii. Ubeti wa pili, nambari ya pili, vivyo hivyo, ukwapi, utao, mwandamizi. Ukwapi, utao, mwandamizi. Mshororo wa tatu, ukwapi, utao, mwandamizi. Ukwapi, utao, mwandamizi. Hiyo ni bahari ya ukawafi. Bahari ya ukawafi. Haya basi, wacha tuangalie bahari nyingine kwa kuzingatia hiki kigezo cha vipande. Ni nambari ya 4 ni Bantudi, au pia ukitaka neno tuo. Bantudi au tuo. Hii herufi na. Bantudi. Bantudi au tuo. Basi ni bahari ambapo unapata ni shairi lenye vipande vinne katika kila mshororo. Ni shairi lenye vipande vinne katika kila mshororo. Aha. Yaani unapata mshororo mmoja una ukwapi, na mimi unafuata utao, mwandamizi, na mwisho ukingo. Kingo. Mfano, ubeti wa kwanza unakuwa na mshororo wake una ukwapi, una utao, una mwandamizi, una ukingo. Vivyo hivyo mshororo wa pili. Ya, unapata vipi? Kuna ukwapi, utao, mwandamizi, kisha ukingo. Kipande cha kwanza, cha pili, cha tatu, cha nne. Haya, ubeti wa pili uko hivyo hivyo. Ukwapi, utao, mwandamizi, ukingo. Ukwapi, utao, mwandamizi, ukingo. Ukwapi, utao, mwandamizi, ukingo. Namna hiyo. Basi katika haya mashairi ya bantudi au tuo, mshororo mmoja unakuwa umegawika mara 4. Kipande cha kwanza, cha pili, cha tatu, cha 4. Haya, nafikiri katika hicho kigezo cha idadi ya vipande katika kila mshororo, umeweza kuona baadhi ya bahari ambazo tunapata pale. Nilianza kwa kueleza kwamba tumesema kwamba kuna utenzi, shairi ambalo kila mshororo una kipande kimoja. Utenzi. Pili, kila mshororo kuwa na vipande viwili. Mashairi ambayo tumeyazoea sana ni mathnawi, bahari ya mathnawi. Kipande cha kwanza kitaitwa ukwapi, cha pili kitwa utao. Hivyo hivyo, vipande viwili kila mshororo. Unaona jinsi mifano ilivyo. Tuingie katika bahari nyingine ya ukawafi, ambalo ni shairi lenye mishororo yake iliyogawika mara 3. Kuna sehemu ya ukwapi, utao na mwandamizi. Ukwapi, utao na mwandamizi. Ukwapi, utao na mwandamizi. Bahari ya ukawafi. Na mwisho kabisa tukaja kumalizia kwa bantudi au pia ukitaka tuo. Nafikiri hayo ni rahisi kwako wewe kuyapata, mwanafunzi. Nafikiri na nina imani kwamba hapo umekuwa na daftari lako ukiandika mawili matatu ambayo umekuwa ukisikiliza na kuyaelewa hapa katika somo letu la leo. Nafikiri kazi yangu itakuwa tu rahisi kwa leo. Nikupe kazi mradi ambapo nitakutaka wewe unitajie bahari 3. Samahani, bahari 4. kwa kuzingatia kigezo cha vipande. Kabla ya kipindi kijacho, basi nenda tafuta baadhi ya mashairi ambayo utaangalia bahari zake kulingana na yale ambayo tumefunza leo kutegemea vipande. Basi mwanafunzi, nataka nikupe kazi ambayo utashughulikia katika wakati wako unapoendelea kudurusu. Kumbuka, mwanafunzi wa kidato cha 4 lazima ufanye mazoezi tena na tena ili uweze kujirakibisha na haya maswali ya mashairi. Basi kazi ambayo nitakupa leo rahisi tena, kama vile kula pipi au kula ini kwa ncha ya ukucha. Haya, kazi nayo ndio hii. Kwanza nitafuta, ili basi usije ukawa tu mtu wa kunakili yale tu nimeandika hapa.